Okay, so we have 4 participants already. Okay, who's here?
So pound, capital T, zero, lowercase w, P, capital R, star, and asterisk, 156.
Good afternoon, everyone. It is 12:53. We thank you guys for stopping by, for taking time out of your day to join the last ACE training of the year. And we will be looking forward to it. Again, we're finally getting everything set up. We're almost ready. If you have questions, I will if you have questions, just type them in the question and answer, and then both Ken and I will be able to see them for you, and we'll be able to answer those. Also, too, there are going to be some housekeeping things, some housekeeping rules. Everything that you see is proprietary, so so of course you cannot share with anyone. But if you have any additional questions, you can email us directly. I will put my email, and also too, I'll put Ken's email in the chat, and so that way you guys can get back to us and get back to us if you have any additional questions as well. And Ken, of course, is going to also put his email up as well. We will get started promptly at 1 p.m. And once once that happens, again, we're going to take it away. Just give us a few minutes.
Okay. Good afternoon, everyone, or morning if you guys are on the West Coast. You guys like to live in the past over there. So I understand completely. Yeah, my name is Ken Summers. I am the technical support manager for Appson here in America. Been with the company for about 3 years now, and doing these ACE trainings. If you guys have called the technical support line, you've probably talked to me at least once over the last couple of years. For a while there, my phone was the only one that was supporting people. So I do have a great team of people now that are helping me out. I have 4 employees that work under me right now, and we are doing the best that we can support everybody in America from a technical support side. So thank you for joining. Hopefully you guys will be able to learn some stuff here so that we can help you guys to be able to not have to rely on us much, or to be able to prepare for your guys' upcoming installations that you have. I would like to get started here. First things first, let me start. Share my screen. Let's share screen number 2 for you guys, and let's go. Let's go. So first things first, little company introduction here for anybody that doesn't know about Appson. Just going to go over information about the country so you guys understand us. If it's the first time you've heard of us, Appson is one of the largest LED manufacturers in the world. One thing that makes us different from some of our competitors, not all of our competitors, is we actually build the panels together with partners in China for manufacturing it. But we put the LEDs on the modules. We put the modules together. We put the boards together. We build everything, or understand where everything is coming from. If we source some stuff out, the only things that are really sourced out are the like the metal aspects of our products, back boxes and stuff. But we design that with our partners that provide those products to us. It is located in Shenzhen, China, and we have a massive factory location about an hour outside of Shenzhen. That is where our factory technically is. Worldwide, we have multiple companies. We are Appson America. There's Appson located in Japan, Russia, Germany is all of Europe, Dubai, Hong Kong, Mexico, and Brazil. Mexico provides support for Central America and Caribbean, and then Brazil provides all support for South America. We have about 2,000 plus employees, a lot of patents, countries. There's Appson products in a lot of countries all over the world, and then a lot of overseas shipping for products everywhere that we go. We value quality control. Really, there's not much when you get the product on site. There's very minimal amount of stuff that needs to happen. We give it a good quality control before shipping it out from the factory to make sure it arrives as a good product when it gets to you. Not saying that it will be perfect every single time, but there is a lot of the manufacturer defects are caught before it gets sent out. And then we always do our repairs as soon as installation is complete, and don't require any additional issues from clients once the walls are built. There is a global level of support. We have Epson trained engineers all over the world. There's about 4,000 plus service engineers that have gone through this ACE certification. This ACE certification is worldwide certification. We do it in every single language, every single country. So we do certify people if you have people in Africa or any countries in Europe. There is a certified people that have worked with our products all over the world. Just a couple of companies that we have products with all around America here. MBA has multiple arenas with our products up in it. Just finished one recently. In Salt Lake City, Disney, we have different companies all over the world that our products are working with. This is an older slide. You can see it says 2019, but we are well above exports for our current one. It's been 13 consecutive years now of being the #1 exporter of LED products. And the company values, we value honesty, responsibility. So we take care of our clients as much as possible. Our partners, we like to make things right if there's any issues with our product. We also like to provide as good of service as possible for you guys all over the world. There's 24/7 support. There's also local support. So my office, everybody that works with me, we are the local support for you guys. But you can always reach out to our headquartered technical support after hours if you're not able to get a hold of any of my team after hours, between the hours of 5:30 p.m. and 8:30 a.m. The support team in China are able to assist with any issues after hours. And then on-site service, we provide installation support for anything that has been sold for Epson. We like to make sure that the walls that are being built are up to Epson standards. So we provide on-site services with most purchases, and then also we can provide on-site services after the wall has been built. It just depending on the time frame, it will depend on if it needs to be charged or anything. And then we also have parts here to easily get you guys parts that are needed for repairs. So that was our company. Quick overview of our company. First thing I wanted to go over in this ACE training is LED basic knowledge. Let's just make sure that we're starting from a foundation here, so that we're all on the same page for the terminology that I'm going to use throughout the course for you guys. I'm going to go through introduction to LEDs. I know a lot of you guys already know this stuff, the basic parts of an LED screen, and then what to know about projects and how to get started from the ground up for most products. So LED pixel, basic LED knowledge here. What is an LED? LED stands for light emitting diodes. There's many applications for different versions of it. There's the 346, or also called the DIP, the DIP pixel, and those are the individual red, green, and blue pixels that are visible on the modules. Then we have what's called the standard mounting device, the SMD pixels, which come in multiple sizes and design applications. And then we also have what our company calls the integrated mounting design, which goes even farther into the SMD. So the SMD is one set of red, green, and blue pixels, and our IMD, our integrated mounting device, is 4 sets of red, green, and blue diodes in the same pixel location as the standard mounting device. Key features about LEDs is longer lifespan than like projectors. low power consumption, but allows high brightness. What the difference between LED and projection is LED, the lights are shining directly at you, so you get a higher brightness than most projection, while projectors you're just looking at the reflection of the light off of a structure or a screen. More truer colors. I do have issues with clients that put an LED wall as a center screen and then have projectors as the side screens, and they complain about the colors not being the exact same. That's because the LED is giving you the true color of the content, while the projectors have fluctuations in their color spectrum. And then also working voltage and indoor outdoor applications that are provided. The DIP, also it's called the 346. The DIP pixel comes from, it gets its 346 name from the millimeter size of it. It's 3 millimeters wide, 4 millimeters deep, and 6 millimeters tall when you look at one of those pixels. And then the SMD, the SMD pixels, standard mount device pixels, they're named by their dimensions. So that example on the screen there, 3528, it's 3.5 millimeters wide, 2.8 millimeters deep. That's where we get those names. Different products use different sizes of pixels. These are our main line of pixels. Oh, I forgot to mention the chip on board option also, and that is not a picture of a chip on board. I need to fix this. Sorry, guys. So you got your DIP, standard mounting device, integrated mounting device, and chip on board. Here's an example of a DIP, a dual inline package pixel module. This is the grandfather pixels, older products. This was the first design LEDs. You don't see this too much nowadays, at least not in our products. All of our products use SMD nowadays. Most of ours are no longer using DIP pixels. You can see the red, green, and blue pixels are very visible in between them. This is for products that are much farther away, outdoor products, billboards, stuff like that, stuff that nobody's going to get close enough to see that, oh, those are actually red, green, and blue diodes that are very visible when you're up close. Then you got your standard mounting device. There's the chip option, which has no black around it. The chip option is usually the bigger surface mounting device sizes. And then you have top LED, which has the black surrounding it. The chip LEDs have a wider viewing angle. And then the top LEDs, because of the black edging, will condense that viewing angle. So the top LEDs are what we use in smaller pixel pitches. Top LEDs are what we use in the bigger pixel pitches. Top LEDs usually start at the 2 millimeter range and up. And chip LEDs start at 2 millimeter and up. Top LEDs are under 2 millimeters pixel pitches because it needs that black for its contrast. And then there's 4 connection points in each one: power positive, a blue chip, a red chip, and a green chip. Then integrated mounting device, IMD. This product has 4 sets of red, green, and blue pixels, red, green, and blue diodes in the same pixel area as an SMD. So the contrast ratio on our products that uses the integrated mounting devices is higher. Because you're getting more colors from the different pixel diodes, as well as the black coating that's put over the pixels. Chip on board, there's 2 types of chip on board. There's the traditional, where the bonding wire is pulled from the PCB board and attached, and then there's flip chip on board. Our products that uses chip on board are Cobalt series. Uses the flip chip option because it's much easier to do flip chip than traditional. Traditional, you have to solder, and those solder points are really small. But the flip chip is just put on the PCB board, and the pixels are being held down by the epoxy cover that is put over the chips to hold them close. That sealing layer will keep the pixels on the PCB board. just some stuff that I talked about for those different options. DIP, earliest, oldest, grandfather technology, cheapest option, higher power use, but also brighter. You only see DIP products in outdoor settings for long distances. So think stadium video boards that nobody's going to get close to, the highway, driving by on a highway, the billboards that you see up on highway signage. Those are products that use DIP pixels. Standard mounting device is the most common used pixel today, used for both indoor and outdoor. Different sizes will allow us to get different usages out of them. And then it's fragile. It's a little more fragile at fine pitches because the pixels can easily be popped off, putting the modules in and out of products. And then our integrated mounting device, it's stronger than the SMD because of the way the pixels are designed, where you can rub your hand against it and you're not going to actually, your finger is not going to accidentally grab the edge of the pixel and rip it off. Much more solid, but it is a little bit higher cost. It does have a lower power consumption for the IMD pixels. Chip on board is completely protected for both physical impact and also environmental factors, moisture. It's not perfectly, it's not IP65 rated, but it is an indoor product that you can take a damp rag to in order to clean it off if needed. But it also is the most expensive because those are really fine. There's a lot of pixels on one panel, and the more pixels it is, the more expensive it is. Excuse me, sorry. A couple of different types of pixels, just give you an idea of what products we're using here. So you got your chip LED, the 0808, so 0.8 millimeters by 0.8 millimeters, 1010, 1 millimeter, 1 millimeter. And then you got your top LEDs, 1515, 2020, stuff like that. Gives you applications for each one. Chip, and then indoor products. These are our products and gives you an idea of the different pixels that we are using for different models. So our Claim 1.2 and 1.5 Plus uses the 1010 SMD. Our A series, the outdoor model, the 4 pixel pitch uses 1921 SMD pixels. And then the bigger pixel pitches uses a bigger pixel, 2727 pixels. Basic knowledge about the screen. Let's just go over the components that are in a screen. So we're going to go from small and work our way. This is an entire screen design. There's the panel, which is provided by Appsen. The control system that we use, there's 2 different products that can use control systems with Appsen products. You have the system that I'm going to go over in this training, Novastar. That is our most common and the cheaper model control system. And then we also work with Brompton for some of our rental and staging products. And that is the more expensive option because of demand and shipping issues with Brompton. Then there's power distribution. Everything that's green on this page is what we provide. Then the brackets, steel structure, subframe. So for all the video walls, that it needs a structure to connect to. We can provide documentation on subframe names. So if you have an outdoor wall that you're building and you need to know where you need your subframe in order for the brackets to be connected to, we can provide you with the documentation to take to a steel fabricator to build the steel frame for the brackets to fit on. There's video processors and video splicers that can be put in line before it, depending on the size of the wall. So some of our more creative options require things like TV1, RGB spectrum, or Extron or something in line before it that all your video inputs go into, and then it sends a single video source into the Novastar processor. So you build the actual video wall processing in a different device, and then send it into the the Novastar processor to send it to the wall itself. This is just a little overview of everything that can come off of it. You have your different applications, control PC to plug in, control, make adjustments to the wall. You have your input PC, whether it be HDMI, DisplayPort, DVI, or God forbid you're working with someone really old and they still have VGA. I want to see someone that has a VGA input on their computer still, seriously. SDI. And then you have monitor outputs. So if the processor is mounted in a rack that's pretty far away from the video wall, you can see what is coming through the outputs of the video wall on those monitor outputs. With some processors have HDMI and DVI. Others are like this one, HDMI and VGA out to a monitor right there. And then you have your data ports for output to the video wall itself. The video walls are daisy chained via Cat5 for communication, and we'll go over that information in a different section. Let's go one component of one panel. So you have one SMD module that is put onto one module itself. So an entire module is made up of so many pixels. Take for example our Acclaim product, which is for example the Acclaim 1.5 that we have. One module is 96 pixels wide and 216 pixels tall, and there's 4 modules in one cabinet. So you have all these pixels on one module. There's 30,000 pixels on the four modules that are put into a cabinet, and then multiple cabinets make up one massive screen. The modules themselves are made up of LED pixels. There's a PCB board that the pixels connect to, IC chips on the back that control the different colors and other electronic parts, connections, power. There's some with housing, so all of our outdoor products have that. All of our products that can be used outdoors have a plastic housing to protect the IC and electronic components from water. Some have mass, some don't have mass. All the models that uses top LEDs do not use mass because the black on the top works as the same black that the mass does. All the products that use mass use chip LEDs for that, and then magnets to hold everything together on the cabinet itself. This is an example of our Acclaim Plus series, 4 modules, 12 magnets total. There's pen connectors for everything. Internal components, there's a receive card in every single product. There is a hub board in every single product. Different models have different looking hub boards. This is the Acclaim hub board design. Every single cabinet has a power supply, some way to power the product itself. And then you have your connection points, data, and electrical. For most of our indoor products, the electrical connections are IEC. For our rental and staging products, they are PowerCon True One connectors for those ones. There's also wrenches that are provided by Appsen for everything. We always provide tools that are needed we always provide common tools that are needed with our products that you cannot get locally. So if you have a Phillips head screwdriver, we don't provide Phillips head screwdriver because that's a common object that can be locally sourced. We do provide stuff like this flexible 10mm wrench because you cannot easily get that wrench anywhere. You have to go onto Amazon in order to find one that's similar. Outdoor products, this is an example of our A series. There's different applications to it. You have modules, alignment pins, holes for the mounting brackets, power and data box on every single cabinet that houses the internal components, receive card, and hub boards, and power supplies, and then holes for cabling for the daisy chain everything together. This is an internal look at the everything that's inside of it. You have ribbon cables for data. You have receive card, hub boards, water resistant ring, and then your Cat5 connections on the inside, as well as power supply. Sorry, I am talking really fast for this section. We can provide some of these presentations for you. Just not this information here is just me going over everything so that everybody is on the same page when I'm talking later in different things. Most of the stuff that is going to be on the test is in the next everything after this. So next thing to describe to you is pixel pitch. When you hear the word pixel pitch for this, pixel pitch is talking about the distance from the center of one pixel to the center of the next pixel. So some of the products, like our outdoor products, will have bigger pixel pitches of 4 millimeters, 6 millimeters, 8 millimeters, or 10 millimeters. That's most of the outdoor products that we sell. Then other products have smaller pixel pitches. Our indoor products will go all the way down to a 0.9 millimeter pixel pitch, and as big as a 4 millimeter pixel pitch in that range. We have some that are 5 millimeters that aren't bought as much for indoor applications. The next term to describe would be resolution. So your resolution is, there's a couple of different resolutions that you talk about. There is the module resolution. So the module resolution is the number of pixels wide and tall that one cabinet is. So when I take this example of the Acclaim 1.5 Plus many times, one cabinet for the Acclaim 1.5 Plus is 384 pixels wide by 216 pixels tall. So that's one panel resolution. Then you have your entire screen resolution, and that's the number of panels that are put together wide and high. So in order to find the resolution of your wall, if you know how many wide it's built as, so take the Acclaim 1.5 as, if you have 5 modules wide, 5 cabinets high and 5 rows tall design, you multiply each design by 5. So for the width of one, which is 384 pixels, you multiply that by 5, and that comes out to 1,920 pixels wide. Same thing with the height, it's 216 pixels tall. So you multiply that by 5, and that gets you 1080 pixels tall. So your resolution for a 1.5 plus wall that is built as a 5 columns, 5 rows tall will be 1920 by 1080 pixels. And not all models will come out to that perfect resolution. Different number of cabinets and different cabinets have different sizes. So you just need to go to your spec sheet and that for the products, and all of our spec sheets online have the width and height of panels to be able to figure out what your resolution is. Also, if your sales engineer provides you a quote, the quote will tell you the exact resolution of your actual wall, depending on the size of it in the quote itself. Next term that is talked about with LED walls is brightness. Brightness is how bright the wall is, and the value that we use for our product is nits. The average brightness for different applications varies from design. Most of our indoor solutions are going to be in the 500 nit range. Most of our outdoor solutions, the semi-outdoor solutions are mostly rental and staging products that can be used in outdoor settings, are bigger pixel pitch rental and staging products, and those will be their maximum brightness range will be in the 2000 to 2500 nit design. And then your outdoor solutions are going to be really bright products. Our current outdoor solutions, the 1 pixel pitch is 7,500 nits, and then the 3 larger pixel pitches are 10,000 nit brightness factors. And these ensure that the content will be able to be seen very, very clearly in broad daylight shining on the cabinet itself. The next term that people use for LED walls is refresh rate. How many times that image is being updated in 1 second of refreshing, of updating on the screen itself. So the left there, you see a refresh rate that is 600 Hertz taken on a camera. So when you're taking the picture on a camera, you will see the lines as it's going through at the lower refresh rates on a camera. The right is 1920 Hertz. Some of the more stable functions will get up to 3840 Hertz range for our products. Our virtual production product lines that we have, the PL 1.9 and PL 2.5 panels, they go 7680 for refresh rates in order to be able to be used in virtual production solutions. Higher refresh rate, the better it is on camera, the less lines you will scan lines that you will see in the image on camera. Your eyes can't see that lower refresh rate because your eyes are fallible and causes issues, but any camera will pick up any refresh rate issues that you might have. Next thing to talk about is accessories. With Apsen products, we provide mounting brackets that are designed for our products. There are third-party companies out there that also provide mounting solutions that if needed, but we do provide very, very simple mounting solutions for any of our products, as well as hanging bar solutions for rental and staging and ground stacking for rental and staging, depending on the solution that you are working in. Another accessory that we have is a vacuum tool, a Dyson. It's basically a Dyson vacuum with a suction cup head on it to protect the pixels. Most of our indoor applications, this is what is used for servicing it because it's just magnetically held on there. The vacuum suctions to the front of the module and it just pops right off with no issues for servicing. And other accessories that you need to know about is the controllers, Novastar controllers, fiber converters. Novastar provides its own fiber solutions for walls that are exceeding the recommended category cable limitations. Light sensors are another accessory that go with video walls. Light sensors are mostly used for outdoor solutions so that it will automatically adjust the brightness level depending on the situation that it's in. So there's some cities that actually require outdoor signs to have light sensors on it because they have they have laws that say outdoor video stuff cannot exceed a certain brightness level when it's dark out, because it will blind people in the pitch black. So light sensors are mostly used for outdoor products. I have put a couple on lobby situations indoors. Those ones for indoor lobbies are like lobbies that are just all windows, the entire lobby, and a lot of ambient light during the day, and at night it gets really dark. So the light sensor allows for the video wall to adjust based on the ambient light in the room. And then other video processors, your RGB Spectrum, TV1, and Longway is another option. And what those video wall processors are for, they bring in multiple inputs, and then they'll send the Novastar processor one source into it, so that the video wall, if you have say it's like a sports bar and you have all these different videos happening in a sports bar situation, what they're using is a processor beforehand portioning out all those inputs and then sending just one HDMI signal into the processor already built with everything on the wall built the way that they want it. Situations like that. Okay. Step 3 in this is information to start projects that you're working with here. The first thing that you need to do for LED projects is understand the application that you are using it in. Questions to ask as you're getting ready to build stuff is what sort of location is this video wall going to be built in? Is it going to be a permanent indoor situation where, say, conference room application, a hotel lobby, classrooms in a university? What is the primary use of this product? Is it going to be an outdoor permanent application? Is it going to be a billboard? Is it going to be a video wall for a stadium, for a high school football stadium to show their scores on? Is it going to be, what is it going to be used for outdoors? Or the third option is rental and staging. Is it going to be torn up, taken down, put together multiple times? Is it for a rental and staging client that just is buying a vast quantity in order for them to use in different locations? Is it going to be used for an XR stage? Is there going to be cameras used on it? If it's a permanent indoor situation, is it going to be a house of worship, the back screen, the backdrop for a house of worship, and they're going to be using cameras on it? Is there, what sort of situation are we dealing with for this application? Conditions for choosing your product. If it's going to be outdoors, you need to have a product that the elements are not going to affect it. If it's an indoor product, what sort of limitations might there be? Is it going to be low enough to the ground that it might get damaged by people walking by it because it's in a lobby? What sort of site conditions do you foresee there being issues with? The next stuff to ask is the wall condition. How is this going to be mounted to the wall that it's being put up on? Is the wall going to be drywall? Is the wall going to be concrete? Are you going to be rigging it, hanging it from the rafters? Is it going to be sitting on the ground? Is it going to be our ground solution options? If it's going to be mounted on the wall, what type of wall is it going to be? Is it going to be concrete? If it's going to be drywall, highly recommend plywooding the entire footprint of the wall with plywood. If it's going to be rigged, is there enough points in the ceiling to hold the weight that's going to be holding that wall? What does the surface look like? For wall mounting, you want to make sure that wall is as level as possible by the GC. But of course, GCs, they are not reliable to give you perfect mounting solutions. Space conditions. Do you need this? Does this wall need to be fully front accessible for all of its internal components for servicing in the future, or does it need to be front and rear serviceable? What sort of situation are we looking at for serviceability? Clearance around the display. Is this going to be recessed in the wall, or is it going to be just mounted straight on the wall the way it is? Our video walls can be recessed into the wall. We usually recommend about anywhere from 3/4 of an inch to an inch clearance around the entire edge of the wall. There's no issue with heat dissipation with our walls. 75% of the LED heat is lost off the front of the module. Only 25% is internal heat from the receive card and power supply. So if it's being recessed in the wall, you can get pretty close around it for recessing it. The other thing to take into account is the viewing distance, so that we can get the right pixel pitch option for the minimum viewing distance. Maximum is not an issue. You can stand as far away from a wall as possible and it will look good no matter what. It's that minimum viewing distance that needs to be accounted for. The closer that you get, the more possibilities that you will be able to see each individual pixel when you get so close. The way that I like to do it in my head for the quickest math is it's 10 feet per millimeter of pixel pitch. So in my mind, if it's the 1.2 millimeter pixel pitch wall, the minimum viewing distance for that is going to be about 12 feet away from the wall itself. The actual math, if you want to get it technical about it, it's technically like 8 point something feet, but I like to overestimate and also it's easier for me to do a multiple of 10 in my head rather than taking out a calculator and saying, oh, that's actually supposed to be, I can do 10 easy in my head. Environmental conditions, temperature of the location. If it's an outdoor one, what's the maximum temperature? What's the coldest that it's going to get? What's the hottest it's going to get? So we can provide the best solution for the temperature location. Ambient light, do you need light sensors for it? How impactful will the sun be on it? Is there any possibility of rainfall? What sort of factors do we need to account for the environment? If it's an outdoor product and it's going to be close to the sea, we definitely need to know that. We have to use a different type of protection for the LED module to prevent the salt water from deteriorating the pixels quicker. The sea salt will cause deterioration if we don't put a specific coating over the pixel to protect it. Time frame. Everyone has time frames for their projects that need to be set up. What is the timeline for your project that you are bidding out an LED wall for? It is important to note that if we don't have the product readily available and built and readily available in the factory, it does take about a month to 45 days to build the wall. And then on top of that, shipping from China, which everybody knows shipping from China is a pain in the butt right now. It's getting better, but it's still a pain in the butt. So we have to plan out timelines for how long it will take to get the product. We do have distributors locally in America that have our most common products readily available to be able to fill your guys' orders quicker. It's just a matter of if it's one of those pixel pitches that we have in America, then we can get it quicker. If it's a complex design, then it has to come from China and it takes longer to get. Timelines, usually it takes about 3 months if it has to come from China to get to you. And budget level, we have different products that cost different amounts to build. So what is the budget level for this project to be able to quote out the best product for the price that the client is wanting to pay? And I already talked about all this stuff, but size and product. So once we get all of that information, minimum viewing distance, application that's being used in, we can provide you with a product that we can provide you either with one product that we highly suggest, which is usually the best product that we have, or if you want a good, better, best option, we can provide you with the three different budget levels for a wall size, depending on what product it is. And then we can also provide you with our design and data flow and power requirements, depending on if you ask those questions for that sort of stuff. I know I kind of flew through that information. This is just basic knowledge just to get everybody on the same page. Nothing from this section here is on the test that you take. Oh, there's a question. Okay, let's go to the next section. What time is it? 1:43. I'm going to do a couple of the next section here, and then we'll take a short break in between the different product lines here. For this next section, I'll take a break after I go over the Epson icon installation. Okay, let's go into this. So this is here, I'm going over our fixed indoor products. This is mostly about fixed indoor applications for installation. The products lines that I'm going to talk about for installation are, I was selected this, are Acclaim 27 Plus, Acclaim 27, Acclaim Plus and Pro. The Acclaim product line also corresponds to some other product lines that use the same mounting structure. I will talk about the Epson Icon 3.0, which a lot of our integration partners are getting. It's a very nice product if you haven't seen it. Our N Plus series will be the third product line. And then Aurora installation. Aurora is our outdoor product line. I will go over that installation. We can take a short break between the Icon and the N Plus installation for this section. So the Acclaim, let me see here. Yes, we will be giving people some of the materials here. It is on record. Reach out to the Epson ACE account for the recording later. Larry, for your question here about multiple setups, repeat setup and teardowns, let's talk offline about your product. I'm not actually going over the Polaris product line in this section here. This is for fixed installation, so we can have a chat about your question. You can email me and we can chat about your question. Question here, what is the maximum distance allowed from LED wall to power distribution using Cat5? Cat5 does not have power for the LED wall. LED walls are powered via local power circuits on the wall. The Cat5, we will talk about Cat5 limitations for data signal in the next section after installation. Yes, this section is on the test. I already answered that. Okay. Let's start out going through the installation for a claim. Oh my gosh. Sorry, my phone's blowing up. The Acclaim Plus and Pro, all the installation information that I talk about in this section also corresponds with our Cobalt, our 0.9 and 1.2, and Cobalt series is the product that has that is our chip on board model, and then our HC 0.9 series, which is for like command and control center applications. It is a 0.9 millimeter pixel pitch also. The mounting frames are the exact same for all of these models, and they are built the exact same way. So all of them correspond with this installation setup. The different models that I'm talking about here, the Acclaim Plus and Pro. Acclaim has actually 4 pixel pitches. 3.8 is end of life. We are no longer making the 3.8. Pixel pitch of 1.2, 1.5, 1.9, and 2.5. The most common pixel pitches that people use these days is the 1.5 and the 2.5 are the most common pixel pitches. And then our Pro series, which uses the integrated mounting device pixels, is the 1.2 and 1.5 pixel pitch. These cabinets are a standard 16:9 ratio, which allows us to build walls in easily to get to the full HD resolution and also 4K resolution. When we say full HD resolution, that is 1920 by 1080 resolution, or most computers identify that as 1080p. 4K is 3,840 pixels wide by 2,160 pixels tall. I will talk about maximum distance in the next section for cabling. So there's questions on the test about what we identify as resolutions for full HD and 4K. So 1920 by 1080 is full HD, 3,840 by 2,160 is 4K resolution. These panels are very light and easy to install. They're also pretty low profile. A wall that's built with our Acclaim product only stands off the wall about 3.5 inches from the wall. And then it uses no ribbon cables or any sort of stuff on the inside. It's a connector on the inside that allows for quick install and change of the modules. Those resolutions, full HD is 1920 by 1080, 1920 by 1080. 4K resolution is 3,840 by 2,160, 3840 by 2160. The next series is our HC series. There's 2 pixel pitches for this, 0.9 millimeter pixel pitch and a 1.2 millimeter pixel pitch. One cool thing about this product line is it uses the IMD pixels. This product line also has the ability to have dual receive card and power supply, which is why we market it for command and control center operations, places that you need high reliability, that wall is not going to go down for any reason at all. We have that optional dual power supply and receiving card in this for even more redundancy protection. And then the third product line is our Cobalt series CL. It is our chip on board model. It is a 0.9. It also has a 1.2 millimeter option for pixel pitch. It's has a high contrast. So the Cobalt has an epoxy cover that that keeps the pixels on, but we also embed we embed black coating in that cover that we put over the pixels, which gives it a very high contrast ratio. The Cobalt contrast ratio is 20,000 to 1 color, and when you see this in person, it's the colors are very vivid and stand out. This is the best product for something that if the client needs perfect color for any reason, the Cobalt gets you that perfect color because of that contrast ratio that it has. It also, the epoxy layer also has waterproof ability to make it pretty durable from damage, but then also you can wipe it down with a damp cloth and not damage it in any way. And then also it has it can be used for TV situations. The epoxy cover hides the pixels, so you don't deal with any image moire effect on with camera work behind it. First things to talk about is our preparation for building a wall. Power and data is very important. We always recommend, we always recommend that power receptacles be built recessed into the wall about 1 to 2 inches. We provide Edison cables that are straight, so it needs a little bit of, it has a little bit of an arc to it in order to, when you plug it in. Our wall mounts are only about a half inch off the wall, and if the cable, if the power outlet is flush to the wall, the panels will not be able to sit over the power. If they are flush, you would need to get low profile cables to replace. And if anybody needs a link, I have an Amazon link to a low profile Edison to Edison plug on Amazon. That is a good product to use. It's only like it's either 6 inches or 1 foot little cable to plug in, and then you plug in the Edison cable that we provide into the other side and tape it together. Works perfectly fine. If you need the low profile option. And very important to make sure that the electricians test, double test, triple test, make sure those power outlets are working and they are wired correctly, because if they are not, you do not want to take that wall down after you build it. It is annoying. I've done it before. Believe me, you do not want to do that. I actually had a job where we had the wall built. It was 20 feet tall by 30 feet wide. And come to find out, once we turned it on, the electricians did not do each outlet as dedicated circuits. They had 2 sets of outlets linked together, and it wasn't enough power. And the wall was not happy with that the ampage that was being pulled off of the circuit. It kept on turning off. The electrician got lucky that the wall was open behind it, and they cut out a hole and climbed into the back of the wall and pulled all the wires from the back. Otherwise, I was not taking that wall down after putting it up. Good example to make sure that they are perfect. We provide 5-meter power cables in every single order. If you need longer cables, make sure you let your sales engineer know. We do have options for 10-meter and 20-meter options, but 5-meter is the base model that we usually send with it. And it's highly suggested that every single wall have plywood backing over the entire footprint of the wall underneath it, so that you don't have to worry about missing a lag point when mounting. Our mounts do not line up perfectly with your standard stud bay locations. Next thing to note while you are preparing for building your Epson LED wall is field conditions. Everyone's worked on job sites. Everybody knows GCs will push you to get stuff done before they should be done. For LED walls, push back on the GC. If it's too hot in there or too humid, you can damage the pixels. I also say the dust will cause issues. We are dealing with that with a job here in Orlando where the dust is causing damage to the panels, and we're having to swap a lot of stuff out because the GC and end user pushed to the wall to be built way too soon. My rule of thumb is if the carpet isn't going down, it's probably too soon to put a video wall in there. If the HVAC isn't running, it's probably too soon to put a video wall in there. That's my 2 cents. Tools that you need for building this wall. Some of this stuff is provided by us. Some of them you need to provide on your job site. Vacuum maintenance tool. This comes in every single order. The hex socket wrench. Do I have one around here? No, I don't. The hexagon, it's a flexible hexagon, 10mm hexagon wrench. That is provided in the spare parts container. You just have to find it in one of the spare parts boxes. What you need to have on site with you is a Phillips screwdriver. Phillips screwdriver is only needed to replace hub boards or receive cards if there's any internal parts that need to be replaced. So if 5 years down the road you go to service a wall, make sure you have a screwdriver with you. Multimeter is only needed to ensure that the power is on and working properly and it's getting the right voltage and ampage. Laser level. The only time you use the laser level is really to start out. Once in all of my wall builds, I only use the laser level for the very bottom row. Once you get that first row on, everything builds off of it pretty well. And then leveling wise, you just need to make sure everything's leveled as you build off of it. The laser level will allow you to do the entire bottom of the wall at the height that you want all the way along. And then tape measure, you only need a tape measure to get it started. Once you get the first row on, you don't need a tape measure or laser level after that first row is built. The Acclaim products have 2 mounting styles. I'm going to spend most of my time on the wall mounting style because the wall mounting is the baseline of everything. And then talk about the rigging also. The wall mount has a lot more nuances to it to make sure that the wall is built properly. Rigging, you don't have the wall limiting how much you can push and pull those panels together. So it's a lot easier to build these walls when there's nothing behind it restricting your movement. Okay, first thing is rigging. First thing is wall mounting. There's 2 different kinds of mounts that Epson provides for these. There's what we call the double wall mount, which is 2 panels stacked together. Those are the bigger ones in this picture. And then there is a single wall mount, which is the very top one here, which is just the equivalent of 1 panel stacked together. The first step for installing on the wall, I like to use 1/4-inch lag screws into the plate. That's why I like plywood backing. So I only have to measure the level once, and then I knock it into the wall and don't have to worry about it. It's annoying with zip toggles to you hold the wall mount up there, level it out, then you mark where the holes are, then you set the mount on the ground, drill out the holes, put the zip toggle in, have to re-level it again. So you're having to do the same leveling process twice, and then screw it into the wall. It's better, in my personal opinion, my background is put it on the wall once, level it once, hit it onto the wall, and be done. The key here is making sure that you get that X, Y, and Z axis as smooth as possible. The more time that you spend leveling the wall mounts before starting to put the cabinets on, the easier the cabinets will go on. Our product doesn't have the best Z-axis control. Third-party products do. The Z-axis control is fixed by using basic wood shims. So purchasing wood shims prior to installation will help you immensely, just to level everything out. And the way that I go about building these walls is putting the level across the face here to make sure that the level is smooth every single time I go across. If one side is higher than the other, then use the wood shims to get that other side level with the side that you need to. And when you put the level up against it, you will feel when you push on it, which side is going to fall forward is lower than the other side. These pictures here are just installation steps. I did this in our warehouse here to show how these panels go together. Oh, back up 1 second. The very far left column of wall mounts, you need to remove this little plate on it. It will be visible outside before putting panels on. This little plate will be visible because the cabinet actually only covers half of it. So the very far left-hand column, remove that little plate. And all it is a M3 Allen key and 2 screws that have an M3 Allen head on it to remove it. So these pictures here are just a little quick documentation of how they go together. There's one double hanging bar solution for the Acclaim panels. You can see my level there. I like to use these fancy levels with digital numbers on it so I can get it as close to perfect as possible. I've been able to build walls if it's like 0.1 degree off in one way or the other. It makes it better if you can get it as zeroed out as possible when building them. And then there's these little nubs that are on the right side of it that bracket actually connects to this, and that will hold the horizontal brackets together at the exact distance that they need to be held together in order for the wall to be built. And then this is the bracket that I was talking about that on the far left-hand column needs to be removed. And these 2 screws here are just M3 Allen screws to take it off. But you put the one to the right on these 2 little nubs, and there's one on the top and one on the bottom of each hanging bar. And then you level out the next one. Usually these little brackets, they can hold it. Usually it's within like 0.2 of a degree of being level when you let go of it. So level it out so that it's 0. And then these are the 2 edges that I put the level across for the Z-axis to make sure that they are smooth. If you run your hands up along between both of these top to bottom, you'll feel if one is higher than the other and needs to be fixed. And that can be fixed by just putting the shim behind the wing here to pull it out. And then top to bottom, there's a hole on the top of the wall mount solution, and this little nub on the very bottom of the one above it. You come in at an angle, put that nub into this hole, and then make sure you level it out to 90 degrees straight up. If there's any fluctuation here horizontally of the next row up, it will cause rotation in the wall mounts and will cause issues when you're going to put panels up. You might be able to put the wall mounts onto the wall consistently, but when you go to put the panels up, the panels will not line up because the panels are much more rigid than the wall mounts are for putting stuff together. So I like to put my level here on it and get this to straight 90 degrees going up. before knocking it into the wall. And then same thing for between bottom bracket and the next bracket. If you feel any fluctuation here between these two for level, it will make it harder for building the wall. So if one of these is lower than the other, use a wood shim behind it to pull it out so that it's nice and smooth when you run your finger along both of these cabinets. And there's a picture of the hanging bar solution stacked together. Depending on the size of your wall will be how many of these you're sent. If you have a wall that is 4 cabinets wide by 4 cabinets tall, you'll be sent 8 total of these hanging solutions. You will have 4 columns of the doubles, and they'll only be stacked 2 tall to give you, because each one of these holds two cabinets tall. So 4 columns, 2 tall, and that's 8 total mounting solutions. If it's a 4 panels wide by 4 panels tall. Epson will always provide the mounting solution based on the size of the wall you are purchasing. Okay, next step, you've gone through, you've built the entire wall mount on the wall. So now you see you're looking at this. You've built all the wall mounts. You've gotten all those wall mounts nice and level up on the wall. Then it's smooth when you run your hands along all these different edges here. Next thing is you need to start doing is putting the panels on. Each panel has you get a bag of these pegs that come with the product. Each cabinet has 4 M8 screw holes on the back that these pegs go into, and these pegs, it's a keyhole design on the hanging bar on the wall mount solution. It's a keyhole design. You put the cabinet in and drop it down, and it falls into place. If you are ever having issues getting these things to fall in, like on the bottom, it's never an issue. They go in pretty easily. But as you start building more and more on top, if you're ever finding that when you put the cabinet in and let go of it, it doesn't drop down perfectly. There's a leveling issue in the wall mount, and you have to find a way to either get around it, or you have to find a way to level out the wall mount in order to get it to fall into place. You shouldn't have to take a hammer to these. They go together pretty easily if leveling is perfect on the wall mounts. You're installing the panels without the frames. I used to say that you need to keep track of the batch number and panel number, but it's not 100% needed. So for the calibration aspect of it, there's a panel number, and then the modules have a panel number and the number of module that it was on that panel. It's highly recommended to put the same modules back in with the same cabinet that it comes out of, but it's not 100% necessary if you don't want to. What I like to do when I'm building these walls is I'll put panels up by the entire row, and then go through and screw the panels together row by row. And when you're going to screw these panels together, you want to close up this gap here and make it as smooth as possible for the modules to sit on it. This aluminum frame should be, any imperfections that you feel on the aluminum frame as you're building it will be exponentially visible on the modules as you're putting it in. So what I like to do is, as I'm taking the panels out of the case, if I see two modules that are already damaged out of the box, I will only use those 2 modules for this entire process, where I will put them up next to each other and make sure those seams are perfect before moving on. Have a question here that they said, where would you start the install? Upper or lower, or any order. So you always start the install, number 1, on the bottom. there's two rules of thought here for installs. It depends on, in my personal experience, it depends on how big the wall is, on which way I go. If it's a bigger wall, so if you exceed 12 feet long-ish, so if it's for the Acclaim product here, if it's a 6x6 panel matrix or smaller, I will start on the far left side on the very bottom and go across. If I'm exceeding that number 6, I will start from the middle and on the bottom and work out. And then once I get that first row level, then I go left to right on everything after that. It's you want to get that any imperfections in your leveling for your x-axis. You want to get it as close to perfect as possible. So the bigger walls, anything's really big, I will start from the middle on the bottom and go out from the middle, and then subsequently I can go left to right after that. Is that bottom row that's the most important. And then the smaller sizes, I will start on the very bottom left and go across, because it's easier to put our frames on because of the way that they're designed. Bottom left facing the wall that you're looking at. So starting on the bottom, and then same thing with the actual cabinets. Once you start putting the cabinets in, start on the bottom left and go row by row as you're building it up. As you put these cabinets on, the added weight of the ones above it are going to make it harder to fix any imperfections below it. So the more time you spend getting these seams as close as possible when screwing them together on the bottom before adding the next row on, the better, the easier it will be to fix anything in the long run. If you run your finger across, and then like I said, if I see two modules that are already damaged out of the box, I will only use those two modules. I will put one on this panel on this seam, the other one on this seam, and I'll make sure that seam is perfect before moving to the next panel in line, and so on and so forth all the way down the line. Once I get to the end of the row, then I'll start from the left on the next row and go all the way across one by one. And you want to get, when you're going up, you want to get all four corners as smooth as possible. So you want to make sure the modules top and bottom are smooth, left and right, top and bottom, left and right as you're building this and going up for these seams. And then it's always important to note, the bigger the wall, the more weight that's going to add to the ones on the bottom, because you're going to keep on adding all those panels above it. And if you don't spend enough time on these bottom ones and you have to go back and fix it in the future, you're going to have a lot of issues trying to fix it, because you have to work the seam imperfection out after you get the wall up. That's why I prefer taking the time on the front end, making sure those seams are perfect before I move on, because it's a lot harder to fix it after the fact. Got a question here that they say, how much leveling / fixing of imperfections can you with the frames as opposed to going back to the mounting hardware? There is a little bit of adjustment that can happen. Our new product line, the NX series, uses the same pegs as the Acclaim series, and we're going to start getting that into it more. But those pegs on the back, in the new pegs, have an Allen key in it, and it's about 4 millimeters of thread. So you can push those pegs out about 4 millimeters on the new design to give you about 4 millimeters of Z-axis control on that. Repeat how you install walls that exceed 12 feet. I start from the center on the bottom row and work my way out, and then all the rows after that, I just go left to right after that. The key is the bottom row. Once you get that bottom row level, everything else connects together and you shouldn't have to worry about the leveling will be the same for everything above it, but that bottom row starts center out and then left to right after that. But yeah, that the leveling after the fact, our new product line and the factories, I've been told the factory, the same screws are going to be used for the Acclaim series. They have a little M3 Allen head in the screw head itself that you can reach from the front, and you can unscrew it and push the frame out. So you have 4 millimeters of Z-axis control once we start using those new screws on all product lines. And that will give you a little bit of Z-axis before having to go all the way back to the mount to fix any imperfections. And then, yeah, like I said, row by row, I always go left to right for the panels, spending as much time as I can to get these imperfections out before adding more weight to the wall as I go. It is really, let me reiterate, it is really hard to fix imperfections in the middle of a wall that is 8 panels tall, and you have all those panels above it just pushing down on the one that you want to fix. It is very, very hard. So the more time you spend fixing it before moving on to the next one, the easier it will be on you when you go to commission the wall. Next. Okay, next step. You have all the panels up. You're looking at all these green hub boards facing you. You don't know what to do. It looks like a massive wall of green blob. Maybe flubber would be nice, you know. But the next thing that you need to do is get the wiring done. Appson will always provide you with the optimal wiring guide for the wall that we would suggest. You don't have to follow the wiring guide perfectly if you don't want to. The next section we will go over how to figure out wiring number of panels that you can do. As long as you're not exceeding the maximum number of panels that can be chained together for power and data, you will be fine. But Appson will always provide what we think is the best way to wire the wall. Power, data, daisy chained together inside the cabinets, and then terminate the home runs to wherever your processor is, whether it's in the rack or in the ceiling. Excuse me, wherever the rack, the processor is at. And then you want to turn the processor on. From the processor, you can go to the display control and turn on a test pattern, and you want to turn on the white test pattern to start out. And I always do it at about 10% brightness. You want to do less than 30% brightness because we want the test pattern on so that as we are putting the modules on the wall, we will see any factory defects that as we're putting the modules up, and we can take that module off the wall right away rather than waiting until getting all the modules on the wall, turn it on and find out, oh, there's 5 modules that already need to be swapped out. We're pulling that off. We're not even keeping it on the wall when we're installing it because we are already seeing that, and we're preventing the number of modules that can possibly be damaged. So then next step is installing the modules. Like I said, that white test pattern, you can see the picture on the right there. You're looking at a huge blob of white. That's why I suggest 10% is what I usually use it as. You just make sure it's less than 30% because your eyes will start feel like they're burning out of your head, staring into that white light, how close you are for a long period of time. So you don't need to have it super bright, just bright enough that the pixels are firing. If there's any manufacturer defects, the pixel will not be white. If it's missing a color, if it's cyan, yellow, or magenta, that means one of the solder points is not working properly on that pixel. So then if it's not white, you just take it right back down, swap it with one of the spares that you have on site, and keep on going. This will save you a lot of going back and having to remove modules and potentially damage the ones around it if you wait till it's all said and done. It's highly recommended to start from the top and work your way down row by row. The reason behind this is, especially if you're working on ladders, there's a lot of possibilities of that module just slipping out of your hand. And if you start from the bottom and work up, if it slips out of your hand, it will take out all of the modules below it. While if you start from the top and work your way down, you're just going to lose that one module rather than damaging any modules that are below it. And then I always like to go left to right because I want to minimize the number of edges that are touching each other as you're putting the modules in to limit the number of pixels that could possibly be damaged during installation. So if you start up here on the top left, you're only one side is touching as you're going across. And then once you start the next row, it'll only be two sides touching per module as you go across. If you want to save time, it is possible if two people are starting from the middle and working their way out. That is another possibility if you want to go faster in this process. You can start in the middle and work your way out, but you want to make sure you are working evenly. So make sure that nobody's starting on the bottom and coming up, because once you get to that middle panel, it'll be very hard to put the modules in on that middle panel. So just going evenly, going from the middle out if multiple people are working on it at the same time. But like I said, you want to minimize the number of sides that are touching to minimize the possibility of damaging pixels as they're going in. This is a little example of minor adjustments that need to be made. You can see this little less than a millimeter issue right here. This can be fixed. The screws can be unscrewed and pulled out on this panel. You have about 1 millimeter of adjustment on the magnet screws to fix stuff like this. If you see something bigger than this, then you have to go to the panel level in order to fix that. But something this small can be fixed by we provide a little. It's a little screw. There's two little pins on it, and it fits onto the magnet, and then you just unscrew the magnet just a hair to pull it out. Yeah, small adjustments that need to be made when finishing like this. After you get all the modules in, you get it turned on. The next thing to do is the LED software configuration. We're not going to go over that in this section here, but 7th step is the software configuration. Software we're going to do tomorrow. Okay, that was wall mounting. Now for the easy one, that's quick and easy. Rigging. It's basically wall mounting in reverse in all reality. So rigging points, you have your hang bar there that you hang on your rigging point, whether it be steel structure in the ceiling, motor, truss, whatever is supporting your wall. The key here is to get these hanging bars level going across it completely, and then you build it row by row going from top down. And you're using the same exact screws that are holding the cabinets together. Now there is a maximum number of panels that can be hung on a hanging bar without adding extra support to the back of it. The maximum load is 10 cabinets down without adding additional support. That is one of the questions. Without adding additional support, you can do a maximum of 10 cabinet loads. If you exceed 10 cabinets, Apsen will tell you how many you can go up to, but there's metal plates that those M8 screw holes on the back that the pegs go into. There's metal plates that go on the corners of the panels to add additional support as you exceed that 10 cabinet recommendation. And you want to get those hanging bars as level as possible before starting to build down. Same thing with rental and staging products that are using hanging bars. You want to get those hanging bars start as level as possible, and then put the first row on. You're using the top screws going into the hanging bar for the Acclaim product. Usually what I like to do is I like to get that first row perfectly level before adding in any additional weight, because it will make it hard as you're going down to finagle it. That you do have more fluctuation with the rigging to get those seams perfect because you don't have the wall limiting your movement, but you do have to take your time. Same thing, making sure those seams are level as you're going top down, and I always go left to right as I'm building my walls. If you ever forget this entire section here, there is a video on Apsen's website, www.usapsen.com/about/video. We have case studies in there, but this Apsen installation video is actually a step-by-step video guide. It doesn't talk anything. It's just it just goes through the flow of building a wall in that video. Maintenance for the Acclaim products, it's very simple. If you ever need help understanding how to make repairs for this product line, you can give us a call. We can talk you through anything from site. In order to access the hub board, you'd use the vacuum tool. You take out all 4 modules and you can access the hub board. There's 11 screws on the hub board to remove the hub board, and the power supply and receive card on the back of the hub board. That's how you do any sort of maintenance to this, is take all 4 modules off of one cabinet, take the 11 screws out, pop the hub board off. 9 times out of 10, the only time people have to make repairs to this product, to any of our product lines, is the hub board is the first fail point. The receive card sometimes causes issues every once in a while, but the receive card is pretty stable. The hub board is the actual connections to the module, and those connectors, those pins that are connecting the hub board to the module, is the most likely culprit of any fail point, because as the modules are getting slapped on there, pins will possibly get bent on accident over time. So if I narrow down my troubleshooting that it's not the module, my first adjustment is always the hub board first, for that reason. 2:30, I think. Should we do a small little break right now? I think so. Let's do a 5-minute break so people can stand up. I know I don't like sitting down for long periods of time. 5-minute break, and we'll continue on in 5 minutes, 2:35 Eastern Standard Time. Okay, so I have a question here from someone. They said, when we get to the maintenance and repair details, is there a source for replacement parts in the US or is everything coming from China? Technically everything comes from China, but we do store some stuff here in Orlando for almost all product lines that are being serviced. And if I can't get it, then it has to come from China. But we do have some parts, a limited amount of parts here at the Orlando warehouse, which is where I work. But it's only parts like hub boards, receive cards, power supplies, pixel repair. All our pixel repair comes to us. If you are looking for stuff like hanging bars, ground support, stuff like that, that has to come from China because I don't have enough space to store vast quantities of hanging bars. Okay, I think we can start going back into this here for the next section. Hopefully everybody's back. Said a little bit after what I said. The next installation is one of our newer products. It is called the Apsen Icon 3.0. This is an all-in-one product design that we have designed for like conference rooms, for school setups, stuff like that. It's a very sleek, clean design, but also like built-in speakers for sound, and then also wireless connectivity, display options, stuff like that built into it. No, I do not go over pixel repair in this course. That is not something that we do for ACE training. It is a little more advanced than something I can do over Zoom. So that's a picture of our Apsen 3.0, our Icon 3.0. There's a couple different options for it. There's a ground cart that it can be set up on a cart and rolled around easily. It can also be wall mounted. It comes in 3 different sizes, a 110-inch diagonal, a 138-inch diagonal, and a 165-inch diagonal. The 165-inch diagonal is only able to be wall mounted. It's too big to put on a cart. All these different sizes are all 1920 by 1080 resolution. So each different size is a different pixel pitch. So the 110-inch diagonal is the 1.2 pixel pitch. The 138 is a 1.5 pixel pitch, and the 165 is a 1.9 pixel pitch, which allows us to keep that 1920 by 1080 resolution size. And its max brightness is 350 nits. We find that 350 nits is the most common brightness used for most situations indoors. So we max out this at 350 nits. That way it can use minimum number of power requirements for it. It has a built-in Android system. You can also add a second Windows operating system onto it in order to have it have its own built-in computer on your system, on any company system. And then that Android card allows for the wireless connectivity and displaying, as well as hardwire. There's HDMI ports for hardwiring connections into it. And then if you have a conference room with a different speaker system, there's a 3.5 millimeter audio output jack to go into a speaker system as well. This does come with an option to do 600 nits. That does add to the power requirements for it, but the base power requirement is 120 amp circuit will power the entire wall. Except for the 165, the 165 needs 220 amp circuits, but the 110 and 135 are just 120 amp power circuit. Same thing with the Acclaim product. Get your power on the wall, recess it 1 to 2 inches into the wall. This is only going to need one outlet, so that will make it a lot easier. I actually had a phone call this morning, someone asking about where they should put the outlet for this wall behind it. There's a wall mounting plate, and as long as you are outside of that wall mounting plate, just barely, you will be behind the rest of the wall, and you can put the power, whether it's in the bottom right hand side behind, or bottom right hand side, top left, top. If you put it in one of the outside corners, you'll be perfectly fine. You'll not get any issues with it, and it will be hidden behind the wall. And that's the only cable that this thing needs, is one power cable plugged into the wall. So I'm going to go over the wall mount, the instructions for both of them at the same time. Both of them are designed to use this rectangle frame solution that comes out of the box. There's 2 long horizontal bars and then 2 shorter vertical bars that are held together with some M8 screws that go through the short one into the bottom one and hold them together. The front has some etching on it, that the etching is always the top, and then the vertical sides have arrows pointing to which way is up. Everything on this will tell you which way to install it. Just follow the arrows. It's easy to do. The next thing will be either your wall mounting solution or your stand solution, whichever way you're going with it, to build it. The stand solution on the outside of the vertical areas here, there's a line that tells you, that has an arrow, and then on the inside of the mount here, the stand mount, there's lines that tell you a number. There's 800, 860, and 960 millimeters. And what that's telling you is if you line up the top screw hole on this with that line, the bottom of the video wall will be at 800 millimeters from the ground, or 860 or 960, depending on which option you choose. That's telling you how far up from the ground the bottom of the video wall will be. And then your wall brackets there, you have your I always mount the bottom ones first, and then measure from you can either put this rectangle plate onto the wall, and you can measure, so you can measure out where to exactly put the top one, or you can measure out to get the top one up there. I find it easier just to mount the bottom ones level, and then put the frame on there to make sure those top ones are perfect. I have the same slide twice, just slightly different wording. Next thing is adding the columns in. So with the Icon, the panels come pre-built in columns, except for the 165. The 165 comes with columns of 5, and you have to put the 6 panel on top. The crates that we send them in, the 6 panel is too long in order to fit in. So for the 110 and the 138, the columns come pre-built, and you just have to hook them onto that plate and go from there. I always build center out. So for the 138, it's 5 columns. So I put the center one on, and on this rectangle frame, there's etching marks, and it tells you exactly where to hang it. So for the 165, there's etching marks that tell you the outside of the center column, and then you just work your way out from there. For the 110, there's an etching mark that tells you where exact center is on the frame, and you butt the two middle columns up to that center mark when you hang it up, and they just hook on to the frame. There's hooks on the top and bottom, and they literally drop on. It's very simple. Once you are putting the columns up, it's a matter of screwing these the columns together through the sides. So the actual vertical seams you don't have to touch. You just have to line up the cabinets, screw them together, and just make sure they're smooth going side to side. What I found is that these screws have a little indentation on it, and it goes into this neck. And when that indentation goes into the neck, it actually pulls the frame to be perfectly flat. And I actually have very little issues getting these things to line up perfectly. Once you get all the columns up, the next thing that you need to do is to install the bottom base. This bottom base is where the speakers are housed, and the processor and Android card are housed. So it needs to be built on the ground. There's plates that screw together. It comes folded in half because it's too long to fit in a crate as the full thing. So it comes folded in half. You have to lay it out flat, and then add the plate in to solidify the two sections here. And then 4 screws that screw into the bottom of the bottom cabinet. There's 6 screws that go into the bottom of the bottom cabinet to hold that up. There's power and data connections that need to be ran into the bottom to power each cabinet and give data to each cabinet, but that's the only data connections. The internal data connections inside the entire column is already pre-installed. You have to do very little wiring for this. It's just 1 cable for power, 1 cable for data into the first cabinet on each one. After you get the base on, install the modules. The modules actually come in boxes that have labels on it. And if you look at the labels on the back of the cabinets, they will tell you exactly which modules are supposed to go in which cabinet. It's pretty simple. Follow the number scheme to build them. And then I always start from the top and work my way down on this as well, because you don't want to drop a module and take out more modules on accident. After putting all the modules in, you attach a trim kit. This has its own pre-built trim kit that goes around the sides here. It's 1 piece for the 2 sides, and it's actually 2 pieces for the top. The top actually comes with little pegs on it that you have to take out, because it's built to become the 165 out of the box. So you just have to unscrew the pegs that are on top, and then you can put the top trim kit on to clean it up. This is a very clean looking design. It usually comes pre-built with all of its installation information. You just have to set up the language, connect the remote, and give the icon a name. So before you finish this step, talk with the end user if they have a specific name for it, if they want to name it whatever the room is. If there's a specific name they want this icon to do, it will show up on their Wi-Fi settings as that name for connecting to remotely to do your Bluetooth sharing. And enjoy the freedom of using the Icon 3. It's a very clean design. The quick sharing option is the Bluetooth option. Then you have presentation, and there's 3 HDMI ports to connect to. So it's a clean design for conference aspects to make it easier on clients that want that sort of stuff. Want a clean looking design, but they don't want to spend money for running cable, or they don't need anything extravagant for the room. Any questions about the icon? Icon is not in the test because it is a brand new product, and I just can put that stuff into this slide deck. If there's no questions, I will move on to the N+ installation guide. N+ is, what's the cost of the icon? Sorry, I am not a salesperson. I do not know numbers. I can get you in touch with a salesperson that can get you cost though. Just send me an email. My contact information will be on the very last slide here. If you send me an email, I will get you in and let me know your location. I will get you in touch with a salesperson that gets you actual costs of specific products if you're curious about anything. N+, is N+ on the test? Yeah, I think so. I can't remember if N+ has been around for a while, so I think there's a question about N+ on the test. N+ installation. So first a little background on N+, explaining the product. So the N+ comes in 5 different pixel pitches. There's the 1.8 pixel pitch, 2, 3, 4, and 5. The 2 pixel pitch is technically 2.44 millimeters. 3 is like 3.18, I think. And then the 4 and 5 are 4 and 5. But this product here is a little more flexible design than the Acclaim. You can see the size here and the different designs. So the base model comes as a 3-module wide cabinet, and then you can add on a 4th module for all of them. And then the bigger sizes, 3, 4, and 5, you can add on a 5th module to make it longer. And the key about this is some of the walls that we build this product on are very creative design situations. They're either huge walls that we want to get use as many columns. We want to cut down the number of columns and panels that are being added into it because of how long the wall is. So we will use the N+ series to get us these longer cabinet sizes and cut down that size of cabinets that have to be built. So if it was the 5 wide design of this, it would take about 2.5 Acclaim panels long in order to do the same area as a 5 wide section of the N+ series. So it's one of these customizable things that we can do to use the right product for the right situation. First step is to ensure that you have enough of the products for what we call back channel is our mounting product, and M8 screws that screw these back channels onto the cabinets from the back. The back channels come in multiple sizes, and what it is the number of cabinets connected together in one. So it comes as a 3x1, a 4x1, or 5x1, or there's also a 2x1 cabinet size. And these just connect that number of cabinets together in one column, so that when you go to put it on the wall, you're putting this entire section up rather than putting individual cabinets on a wall plate. Same thing with the Acclaim, everything. When you go to prepare it, make sure there's power outlets, 1 to 2 inches recessed. That back channel for the Acclaim series is about 1/2 inch as well. I said Acclaim. The back channel for the N series is about 1/2 inch deep, as well as what the wall mount is for the Acclaim series. So the power does need to be recessed into the wall just a little bit in order for the plugs to be plugged in. and make sure those power outlets are tested and verified. I cannot reiterate that enough, I hope. You do not want to be in the same situation that I had to be in for some of these walls that aren't wired correctly. It gets annoying. Same thing with the Acclaim. You want to make sure wood backing is over the entire footprint of the wall. The mounting locations for the N-Series also does not line up perfectly with your standard stud bays for most installations. So either plywood backing or a steel structure that can be built in the right locations for these walls. So first things first, when the N-Series, when you open up the crates, they come with the modules already on the cabinets. For the smaller pixel pitches of the 1.8 and 2, it is highly recommended to remove all the modules from the cabinets and set them aside in a crate for safekeeping until you put them up. If it's the bigger pixel pitches, all you have to do is remove the outside ones. So the ones that the cables are running through and the mounting locations, because these bigger pixel pitches are much more durable for the installation process, that it's harder to damage the bigger pixel pitches. The pixels are far enough from the edge of the module that they are fine. Each module has a ribbon cable and a DC power cable for connection. First things first, when I'm building this wall is line them up in the sections of the back channel. So if it's three cabinets tall back channel, take a packing blanket, lay it on the ground, lay these cabinets face down, and put the back channel on the back. Each back channel has holes on it. There's these small holes which line up with the mounting locations for it on the back of the cabinets. And then the long oval holes are the holes that you mount to the wall in. And what you do is you go straight from the front of the cabinet into the wall through the front of it. What I like to do when building this is I will lay the cabinets on the ground, put the back channel in, and I will finger tight these M8 screws onto the cabinets. And then I will stand up the entire section of back channel like this. And what that does is it will collapse down any gap between the cabinets. And then I will take my Allen wrench and tighten them all the way down once I stand it up. That way I close up any gaps that are in between the cabinets prior to building them. Another thing that you can do while building these back channel sections is pre-wire them with data jumpers and power jumpers in between, especially if this N-Series wall is being built like in an arena and really up high where you need cranes and lifts and stuff to build it. If you pre-wire it on the ground, it will limit the amount of wiring that you have to do once you get up once you get it up and installed in the location that it's going to go. Just saves you a lot of time in that aspect of it. When you go to install these panels on the wall, these are your mounting holes. They're behind the 4 corners modules for each section. That you only need on the bigger sizes. These are the only modules that you need to keep out when going to install on the wall. I like wood backing so that you can mount it straight to the wall and get it and level it only once. Same thing as I said with the Acclaim. Hold it up there, level it, knock it into the wall. That's my preference. If you want to hold it up there, mark out the holes, drill out, put a zip toggle in, go ahead and do it. But I like to make my life easier personally. Yeah, mounting to the wall. I always start on the bottom left-hand side and work my way across. Once you get that bottom row of cabinets together, and leveled perfectly, everything else that you build, you're going to just set on top of that one as you go along. So if you have multiple sections, like say you have a wall that is 7 cabinets tall, and Apsons are going to provide you with one section of 4x1 back channel and one section of 3x1 pack channel, because that's the optimal way to build. We would want to build it in cabinet formations. So then I would always use the smaller size first, because that's going to be lighter to hold up. Four cabinets is a lot heavier than 3 cabinets. 5 cabinets is a lot heavier than 3 cabinets. So I always like to use the smaller size as my base, so that we don't have to break our backs holding them up there and getting it leveled and connected to the wall. And then that bigger section, we can just go and sit on top of that smaller section, and we don't have to hold it extensively. Another thing that I do, I don't know if it's right for other people, but the only one that I will actually connect all 4 screw holes in is the first one that I put up. Everything else I do the far side one, because so from this back channel to the back channel, the next panel, it's only about 1.5 inches, 2 inches away. So I see no reason to put another lag bolt this close when you screw them together and they're right there within 2 inches of each other. This lag bolt is going to take the entire weight of this section together. That also frees up the ability for me to get these seams as close as possible, because I'm not screwing this section in. This right side here, as I'm screwing the side cabinets, the cabinet sides together, I have the flexibility to line up those modules perfectly before rather than fighting with the wall, limiting how much I can adjust it. This is the side screws that I was talking about. Same thing with the Acclaim. Oh, I need battery. That would have been bad. Perfect. Sorry guys. These are the side screws. They're pre-installed into the cabinets to go from the left side into the right side of the cabinet next to it. We also send M6 by 60 millimeter nuts and bolts for top to bottom. If you build the back channel sections correctly, you don't need to add these into every single cabinet in that back channel section. You just need these bolts to go from section to section that are not connected together via that back channel. So when you stack one on top of it, you need these bolts to hold the cabinets smooth to the next section above it. Once you get it all up on the wall, data jumpers, get it wired the way that it needs to go. Power jumpers, wired the way it goes for power and data. And same thing with the Acclaim products that I said with the Acclaim products. Turn on the white test pattern at less than 30% brightness. I recommend 10% because it's better on your eyes. But as long as you're less than 30, it's perfectly fine. And then start installing the panels. So the cabinets have an arrow that points up to show you what top is. The modules always need to be pointed up. One thing that I didn't mention about the N series is it has the ability that you can rotate the cabinets and build it in portrait mode. When you rotate the cabinets, you need to make sure that the arrow on the back of the module is facing up no matter which direction the cabinet is facing. Then in the Novastar software, we actually rotate the receive card file on the cabinet in that form. Same thing with the Acclaim products. Start from the top to install the modules and work your way down. If it's the 1.8 and 2.4 millimeter pixel pitch where you take all the modules out, you'll see that there's the ribbon cables and the power cables. They're just dangling there and giving you a headache. By starting on the very top left-hand side and working your way across, you're actually stuffing these ribbon cables into the wall as you're going and getting them out of your way, rather than fighting with them from the bottom and working your way up. If you start from the bottom and go up, you're having to pull the ribbon caves out of your way and pop them in. If you start from the bottom, you're hiding them as you're going in. Little example of the N-series panels. This was a wall that was built really, really bad by someone. You can see in this picture the different back channel sections. So this is one back channel section, 2, 3, 4, 5, 6, 7, 8, and you can see these seams. The people that built this wall, they did not connect those side screws properly, or the bolts in between the sections. So as you can see, those back channels, they hold those panels together really nicely inside of them when they're screwed down tightly. But if you don't add the bolts between the sections, that's where issues start forming vertically, and your vertical lines for the sides not properly screwed together. Our technician went out to site. They had to take the entire wall down and rebuild it. And then by adding in those bolts and screwing the side screws together, this is the final. It's the same exact wall, just rebuilt properly. Couple of examples of other N-series walls that are out in the wild. The Prudential Center in New Jersey for the Devils, that is an N-series wall. We actually just got done building, redoing all the LEDs in Salt Lake City Arena. Those are N-series walls that were just redone. And then this World Equestrian Center is up the road from us in Ocala, Florida. That is an N-series wall. This is just an example of what you can do with the N-series design. They are bigger panels for stuff like this to do. Any questions over the N-series? Same thing as with all of our models. As long as you take your time leveling and making sure that the modules are flat, it's going to look perfect. It's going to look great. Last one that we're going to talk about installation of is our outdoor product, the A series, also sometimes called Aurora. If any of you have been working with us for a long time, our predecessor to this was called the XD Plus. The mounting style is exactly the same as the XD Plus. The only difference between the XD Plus, we designed it so it can easily be upgraded from the XD and XD Plus series to the Aurora series without having to get a fabricator to come out and rebuild the steel structure. All you have to do is take the existing panels down, and the base model for the A series, for every 2 XD Plus panels is 1 Aurora panel. It's the same exact size as 2 panels side by side of the XD. There's different size options for different situations, and you can talk to the sales engineer about what the best option is for your project. But the base model is 1,280 millimeters wide by 960 millimeters tall is the base. And it comes in 4 different pixel options, 4.44 millimeters, 6.66, 8 millimeters, and 10 millimeters. The 4.44 maxes out at 7,500 nits. The 6 and above all go up to 10,000 nits, and it's very, very, very bright. Let me say that, very bright. So the first step to building this wall is getting the structure built properly for whatever application that's being used on. You can reach out to us for the CAD drawings. If you have a specific A-series wall already being quoted, we can give you the specific CAD drawings for how it's being designed from HQ, and we can give you the exact measurements of where you need to do these vertical bars at and horizontal bars. If we already have a quote out that's been approved, and you need and this is going to be the wall that you're going to build, we can get you this as a part of the wiring schematics. If you ask your sales engineer for a structure schematic, they can provide that. The key here is your verticals. You want them to be on center, 1,280 millimeters from left to right, so that the mounting plates can be sandwiched between it. And then if you want rear service accessibility, any horizontal plates need to be built so that they do not block this center cabinet from the door from opening. So if it's 960 millimeters from center to center horizontally, you will not block the center cabinet. Diagonal dimensions on the Acclaim series in inches. Yes, the 27 we call the Acclaim series is called the A27 because it's a 27.3 inch diagonal. So yes, the Acclaim series is in inches. But for the A series here, you want your structure built to be able to mount to prior to going to site. It's key also to make sure your steel structure that they make sure that their points are as close to level as possible, no matter how far away it is. I have been on job sites where they did not get those vertical steel bars perfectly level, and you'll need to get like metal washers and stuff to use as shims to level it out on the face for the Z-axis. First thing that has to happen is we have to take out the outside module. This picture here is the XD panel because I don't have updated pictures for the A series yet. The only difference is there'll be two modules between this one. So you take out the very top right module and the very top left module that is 3 modules over from that one. And then same thing on the bottom, very far bottom right and very far bottom left. So there'll be 2 modules here in between on the Aurora panel that you don't need to take out. And there's four screws in the corner of each module. And we provide this Allen key T-bar that you unscrew those screws that are inside there, and then the module just pops right off. The mounting structure that we provide is this plate. We suggest you use something along the lines of like shallow strut, half strut for depth. So if the steel structure company provides you with something that's about half inch thickness or so, 3/8 inch thickness, I wouldn't go bigger than 5/8. We provide M6 by 10 millimeter hex bolts to screw from the mounting plate through the front. And as you can see here on the mounting plate here, you have the 2 holes. That one goes on one panel, then the other hole goes on the other panel. For the bottom, you're only using these bottom 2 holes. If it's in the middle of a section of cabinets on the top, you'll do the bottom holes on the bottom row and the top holes on the next row above it to hold all four modules all 4 panels together in the same area. Then there's also some M6 by 60 millimeter bolts and nuts for going side to side to secure the sides of these cabinets together. Same thing with all of our other models. Whatever you feel on the frame here will be visible on the modules once you put the modules in. So get this frame lined up here. You can see they had to use a metal washer to level this out Z-axis wise for these two cabinets. So same thing here. If you need to add metal washers to level it out, use that. Get these as flat as possible. If you run your hand up against it and it's smooth on both sides, screw those nuts and bolts down all the way, and that will secure it pretty well. This is a finished product here of what a wall would look like. This is XD Plus panels, but it's the same exact design aspect to it, where the A series would be similar design. Next thing will be wiring, data, and power. So with the new A series, there's data and power jumpers already pre-installed on all of the cabinets. It's just a matter of taking a little jumper to go from one cabinet to the other. Our new cable design is very specific for this model. It's not a PowerCon True 1 on this model. It's not a network cable. It's a waterproof cable that goes together. So make sure you have plenty of those cables in the order. I don't have a cable here with me, otherwise I would show you one. It's pretty cool. They actually screw and lock together to increase the waterproof ability. Test the data, test the power, turn the cabinet on. People ask me, where do they put the light sensor for walls? You want the light sensor to be somewhere where it will be like the sunlight is shining on the face of it, so that you get the right brightness. Some people will, if it's high enough up, they will take a little L bracket and secure it right above it here in the center, and so that the light sensor is getting whatever light is shining directly on the face of the wall, so that your brightness adjustment is adjusting based on what is hitting the wall and making it look good. You don't want the light sensor to be facing the back of the wall or facing the opposite way. If this is an open back, like a billboard out in the middle of nowhere, if that light sensor is facing the opposite way, you're not getting at the accurate light reading that's hitting the LED pixels themselves. You want the brightness adjusted based on what's hitting it. The ways to do maintenance with this product here. In order to do maintenance, you have to remove all the modules in one location. There's those 4 screws on the 4 corners. There's a little maintenance knob here that comes with it. There's a screw hole in the very center that this knob will go into, and that's how you pull the module out when you have the wall completely built, so that you don't damage any of the modules around it. In order to access the center hub from the front, you have to take all 6 modules off to open up the gate here. One update that we did from the XD Plus series is these horizontal brackets here are now in line with the back plate, so that you don't have to take these horizontal plates out. The XD Plus, you had to remove these horizontal plates. Now these stay in. And then there's screws at the top, and it leans forward and comes out. And then you can open it up, do whatever adjustment you need to fix on the inside while it's leaned forward, and then you can put it back in the reverse way, put it back up, screw the power box back in on the top, and then put all the modules back in. It is very important that with this model, when you take the modules out, put the modules back in, that you screw the 4 corner screws down as tight as possible to close that waterproof gap, to prevent any water from getting behind the module and getting into that power box. I have seen clients, whoever went out to look at the wall, they got lazy. They just kind of half-heartedly screwed these, or they only screwed 1 or 2 in, they didn't screw all four back in, and water got into that center hub and caused damage to the internal components because they didn't close that water seal all the way. Another thing that I have, this model is designed to survive the elements as long as it's powered on completely. This doesn't need to turn off during off season. I had a service call for a client for a theater up in upstate New York that they had to replace all their hub boards because they decided to turn the power off to the entire wall during their off season. And it's designed that the power supply, even when the pixels aren't lining up, the power supply will keep that center cabinet warm enough so that those hub boards don't freeze over. And they lost all of their hub boards because they froze in upstate New York winter. This is the end of this section. There is my contact information. I will leave that up there for a second. Is it suggested, the question here, is it suggested to use a precision torque screwdriver? And if so, what setting? You can use a precision torque screwdriver. I use it to speed up my removing modules and removing hub boards and stuff, especially if I have a lot to do. I usually don't set it much more than 2 or 3 on the settings. It doesn't need to be super tight, super strong. So I would set it pretty low so you don't over torque it and cause damage to any of the components. Any other questions about installation? Oh, I wouldn't use a precision torque screwdriver for waterproofing. I'd tighten it down as tight as you can get it with your hand. Got a question here. It says, can we install a manufacturer enclosure to trim the edges? Some of our models do have manufacturer enclosures. Our new models, that I didn't talk about in this design, the KL and the NX series, they're brand new models. They have manufacturer trim kits that actually come when you order it. But for all of our other products, the N series and the Acclaim that I talked about here, we do not have a manufactured one. There's third-party companies that do have trim kits that design it. For some of our third-party companies, you have to buy their mount in order to have their trim kit used for it. So Draper, Peerless, and Adaptive, they all have a mount designed for the Acclaim series, designed for the N Plus series. But the trim that goes around it only works with their mount. RCI Custom has a trim kit that can be purchased after the wall's been built that just screws onto the side of those products if you need trim after the wall's been built. And then should it be ventilated? So the ones that are designed by RCI Custom, the bottom and sides do not have ventilation on it. The top does to let it go out. If you have any enclosures for especially outdoor walls, put the ventilation on the top of it so that the hot air can escape out the top. But like I said earlier in our LED knowledge here, 75% of the heat dissipates off the front of the LED. There's very minimal rear heat that comes off. So the ventilation, a little bit of ventilation is okay, but it doesn't have to, it's not going to kill it if you don't have holes in the trim kit. Got a question here that says, what is the vacuum for then? The vacuum is for all of our fixed indoor installation products. The outdoor one is screwed in and has screws, but everything that's indoors, you take the modules off with this. I don't like using this during installation. I put the modules in by hand because I put them in one at a time. But this is for maintenance to access modules in the middle of the wall once the wall's been already built, so that you don't have to take all the modules out from the side of the wall in order to access a module in the middle. What time is it? 3:30. I'm going to keep this up here. I'll give you guys, let's do a 10-minute break here. 3:40 Eastern Standard Time to do the next section. Okay. 340 here. I think we can get back into the next section. I do have a couple of questions here that will answer. Oops, I didn't want to stop sharing. Sorry. I do have a couple of questions here that I'll answer that was put in while we were on break here. Pertaining to the PL series version 10 XL, and is there an equation, or how would it be best to calculate the curvature? So we know if to start at X measuring the curve would be this much and Y. So the curvature is giving you the degrees that it is curving. So if you put it at a 2.5 degree, it's going to be a 2.5 degree around the entire thing on that back. That's what the curvature section on the PLs provide for you. So the PL series, for those of you who don't know, can do 10 degrees concave, negative 7.5 degrees convex built into the panel side, and it has a little adapter. It has the connection point on the back. It tells you 2.5 degree increments of curvature, and that's the entire curve around that you have going around it. Is there another session beginning in a little while? Yes, I am going to do one more section here going over power cable and signal cable, but also some Novastar controllers. The test takes place after tomorrow's session. We will give you until we will issue you a link to a Word document, and you will have until Monday to finish the test for credit. It will be, you'll have all weekend to do it. It's open note, open book, and open notes. Do it whenever you can over the weekend, and as long as it's back to us by end of day Monday, it will get graded. Another question here. Is there a VIXA certification for this course? Not yet. We actually just put in our request for a VIXA certification last week, and we're waiting for a VIXA to approve it so that it will be a VIXA certification next year. We are working on getting a VIXA certified, but it's just not yet. Okay. Any other questions, comments, concerns? Any course for repairs? You can reach out to us individually. The issue with that is all of my repair technicians don't speak English. So it's kind of hard for teaching repairs, but we can probably work something out with you. It will just take some finagling with schedules to see if we can get you something. Just you'll have my email address. Every single slide will have my email address at the end of it. Send me an email and we can see what we can do for you. Okay, first things first, powering data sheet. Like, what time is it? 3:45. Yeah, it's getting the end of the day. That's why I can't talk. Power cable and signal cable. So in this section here, I'm going to show you Apson's recommendation for figuring out the maximum number of power and data cable runs that can be done for walls, so that if you don't have your quote in front of you, if you don't have the drawings in front of you, you can figure out how to wire a wall quickly in the field if you have no internet connection to look up our screen calculator. And I will show you the screen calculator before we leave also. First things first, let's go over the different models of LED controllers that Novastar provides. There's two different styles. one style has no built-in scaling, while the other style does have built-in scalability. The first one is just called independent controllers. Everything on this page has no built-in scaling. So whatever goes in via the HDMI is what's going to go out the network ports in that order. So if you have a wall that is not a perfect resolution, you have to scale it before this processor and send the exact resolution of the screen into these processors in order to run that model of wall. The ones that I have squared are they are the same basically the same exact model, just the only difference is you can see one has an LED faceplate on it, the other one does not. Some people might prefer the one with no LED and model on it if they don't want people to mess with it in the field. So say it's somewhere like a house of worship, and this church has that one volunteer that always thinks they have to mess with stuff. Give them one that doesn't have a faceplate, so that that person cannot make adjustments to it, because you'd have to have a computer to make adjustments to it. Situations like that will be when you give them the option with no faceplate. These are the maximum pixel sizes for these processors. What this is saying is this is the maximum number of pixel output that processor can do. So the MCTRL 600 can do a maximum output pixel capacity of 2.3 million pixels. The 4K, the MCTRL 4K can do a maximum pixel output of 8.8 million pixels. And when I go into the math here in a second, that's where these numbers will come in handy for figuring out stuff like this. And that's why we need to understand what is the maximum capacity that these processors can do. One question on the test, just to give you a heads up, is asking you what is the maximum pixel capacity for the MCTRL 4K? And I just said the answer, 8.8 million pixels. And yes, everything that's on this page right now has no scaling built into it. So whatever goes into that HDMI port is what's going out to the wall, pixel to pixel. There's no adjustments that can be made with these processors. Go over these models a little quickly just to give you a little overview of them. The 660 here has one HDMI input, one DVI input, 4 output network ports to the wall. Your maximum capacity is 2.3 million pixels. And then this maximum output here is just telling you how much maximum we can go wide and high. One thing to note is as you go wider than 1,900 pixels, 920 pixels, you're going to lose height. So it can do some custom resolution designs on its input. You will make limitations. The pixel processing has to come from somewhere. So when you go wider than 1920, you can only go so high. I don't remember what the height limitation is when you're going wide, and vice versa. As you go taller than 1080, you lose the pixels on the side going higher. And then this layer here is how many sources can be played at one time. So you can only do one input source going at one time with this one here. It's very basic, no scaling, no nothing. Very, very, the cheapest of the cheap if you need it. Next up model is the MCTRL 700 or 660 Pro. This one's a little more high tech than the 660. It has 6 output ports, but it still has that 2.3 million pixel capacity limitation. This actually has fiber that it can do outputs for. And then it has one HDMI, one DVI, and a 3G SDI input for this. It also had the 660 Pro also has Genlock functionality and network controllability. So some of these processors can be controlled via IP protocol, and the 660 Pro is able to do that. Got a good question here. What is Genlock? Genlock is for camera stuff. Genlock is how we connect, how the processor and cameras will connect together to prevent any scan line issues that you might be seeing, or sync up the videos that are being played and seen through the camera lens. Most times, if you're using a camera system on an LED wall, you want Genlock to be there in order for everything to be talking together and hopefully get most of those scan lines that might be visible without Genlock out. Next processor, the MCTRL 4K. It has one display port, one HDMI port, and two DVI ports. Those two DVI ports are to do image mosaic aspects, so that you take two 1920 by 1080 resolution inputs and make it into a 4K wall together. The maximum load capacity is 8,800,000, 8.8 million pixels. It has 16 Cat5 category outputs and 4 fiber output options on it. Keys here with the MCTRL 4K, it has high definition resolution functionality, low latency mode, and then also able to do fiber backup and duplicate. One key to talk about with this, if you are using HDR, high definition resolution, or low latency mode for this processor, it does cut the output capacity of the ports in half. The pixel capacity has to come from somewhere in order to do that processing ability, and all of the ports get cut in half. And I'll talk about what the maximum normal pixel capacity is here when we start doing the math. Any questions on the MCT, the controllers, just the independent controllers, no scaling? Awesome. Next one, all-in-one controllers. These ones have built-in scalability designs. You have the VX4S-N, VX600, VX1000, and the Nova Pro UHD Junior, the big boy. We'll talk about why that one's so good. The VX600, VX1000, they're brand new products that Novastar is coming out with. VX4S -N replaced the VX4S. The only difference between its predecessor and it, they took out one VGA input, I think it was. They took out one input of some sort to downsize it, and it became the VX4S-N. Yeah. And then the UHD Junior, same thing here. There's your pixel capacity for each of those processors. The VX4S-N is 2.3 million pixels. The VX600 is 3.9. The VX1000 is 6.5 million pixels. And then the VX16S and Nova Pro UHD Junior is 10.4 million pixel capacity. Go through each one of these processors for you. So your input options for the VX4S-N, you have a display port, HDMI 1.3, DVI, VGA, SDI. Yeah, they took out one VGA port. And then 3G SDI, one 3G SDI. It has 4 network ports, and then you have those monitor options, a DVI monitor, and then also a DVI loop through. One important feature to say about this, and this has been I say this because it's been a question that I've answered on the tech support 800 line many times. In order to use the DVI loop through, you have to go in DVI. It is a passive card in there, and it doesn't actively switch. So you cannot go into the processor HDMI and expect to come out the DVI loop through. It doesn't pass through that way. You have to go in DVI in order to loop through it to another processor with the DVI out loop through. Question here says a claim series processor is built in, right? The claim series, no. The icon, the processor is built in. Every single other model needs a processor separately besides the icon. VX4S, you can do 2.3 million pixel load capacity, and then see the layer option here. You can do a maximum of 2 windows. So you can do a HDMI and a DVI input in here, and you can do a picture-in-picture by putting one of them in the top left section here if you have those 2 inputs going into it. Next one is the VX600. You have your HDMI 1.3. You have 2 of those. You have a DVI, 1 DVI input, 1 SDI input, and you actually have 2 fiber inputs. 6 network port output ports, 2 fiber output ports, your HDMI monitor, and you have an HDMI loop through and a DVI loop through and an SDI loop through on this processor. 3.9 million pixel capacity, and then you can do a maximum of 3 layers on this one. So 3 different inputs playing at one time on this. This processor has that same low latency mode as the MC-Tiro 4K. It has what's called the bypass mode and a fiber converter mode. So with this processor here, you can get 2 of them and use the second processor as a fiber converter. So you can go out fiber at your rack where you're inputting your source, and then connect to the second processor on the far side and come out the network ports on that second processor into your wall, and it works as its own fiber converter on the other side. Your VX1000, you got 1 SDI, 2 HDMI 1.4s, 2 DVI inputs, and 2 fiber inputs. It's 10 Cat5 outputs. Ignore this picture, it's the VX600. It has 10 network outputs, 2 fiber outputs, and the same thing, HDMI loop through, DVI loop through, SDI loop through. Same thing as with all the other ones, you have to use the input that you want to loop out of. They are passive cards, they are not active cards. So it's in DVI, out DVI, in HDMI, out HDMI. I don't like getting those calls, ask me those questions. 6.5 million pixels. And then you have your 3 layers that you can do on this as well. Same thing as the 600, low latency mode, fiber converter mode. You put 1000 in the rack with your computer going into it, and then the other one on wherever you need that fiber output at, and you run the video signal fiber and use the network ports on the second processor as your output to your wall. And the new Nova Pro UHD Junior. You have 4 DVI inputs, 1 HDMI 2.0, 1 DisplayPort 1.2, and 2 12G SDIs. 16 Cat5 ports, 4 fiber ports, and then you have your loop throughs also. 10.4 million pixel capacity, and you have 3 maximum layers that you can do on this one. You can do the same thing with the 4K DVI mosaic mode. This one has 3D functionality if you're using a 3D processor, your high def resolution, your low latency mode. It can do the fiber converter mode as well. Remember, with these modes here, it will cut the port capacity in half in order to run those modes. Novastar also has a brand new video splicing processor that they are using nowadays. The H series comes in 4 different sizes: H2, H9, H15, and H5, and that number pertains to the number of rack units that the processor is using. So the H2 is only using 2 rack units of space, 9, 15, and 5. And what this does is just from the traditional solution of how we used to do stuff, where you have your input going into a video splicer, say TV1, Anlongway, something like that, something to splice the video up, and then it sends it out to all the different LED controllers that build the entire wall. So say you have a sports bar that is a massive wall with multiple inputs going to it. You actually build the screen size on the video splicer, and then you output each individual locations to the different processors that's controlling, and then the processors go to the wall for Cat5. This here, you're going one input in, and it has multiple inputs and outputs on it, and you can send this, you can do everything that you're doing in that video splicer in the H series splicer, and sending it straight to the wall via Cat5. So this here, this new processor is cutting down all the fail points between the video splicer and the Novastar controllers. So all these either HDMI, DVI cables that would have been here, and it's also saving space in the rack because it's less cables to have to try and hide inside your rack. There's multiple input card options. It's kind of like think Crestron DM chassis. You're buying the chassis with input and output cards. There's multiple signal types that you can do with it. HDMI, DVI, whatever. You can get it built whatever way you need for the solution that is being run by it, with multiple output cards as well, for fiber or just Cat5. Any questions about processors? Regarding the independent controllers, although there's no scaling, where are the X and Y axis shift options? My experience is I will go over X and Y shift options when we talk about the Novastar software tomorrow. When you build the screen, you can adjust where the LED wall starts its image at for its starting point. All the XY shift options will be when you build the wall in the Novastar settings. If you're not using mapping software. So some of the controllers, you can actually move the XY location on the processor itself in the menu. It's just a lot harder to do than using the mapping software, and time consuming. There's a on the menus of the processor, there's a option that says output settings, and under output settings, you can adjust the XY location. It asks you where the XY location is you want to start. Sorry, I need to turn around and look at the processor to make sure I say the right words. Any other questions regarding the processors before moving on to the math? Everyone loves math. Awesome. Moving on. Cabling. One important thing to tell you about cabling is our panels are unidirectional. It doesn't matter which port you plug into. There's no right or wrong way. Input, output, it doesn't matter. They pass both ways. So my personal preference when I'm cabling a wall, I always cable to the next one in line. So if I'm going up in the chain, I would go out of the top port into the bottom port of the one above it, just so that if I take the module off on this cabinet here and I look at the cabling, I know that the top port is going to the one above it and the bottom port is going to the one below it. In my mind, that makes servicing easy in my mind. You guys can, if you think I'm wrong, you guys can wire whatever way you think is the best way. But when I go to service this, I would want to know this cable is going to the one above it and this cable is going to the one below it without having to take the modules off above and below. There's multiple cabling types. So you got your Cat5. Our rental and staging products come with Ethercon heads on it for the panels. The Ethercon head allows for locking of the network ports into the chassis, so they don't accidentally come apart when lifting them up. Got a question here. Does unidirectional cabling hold true for end-of-life products? Yes. Unidirectional holds true for all of our product lines. Okay, and then you have your power cabling, IEC cable, which is rated at a 10 amp draw. IEC cables are for all fixed indoor installation products. So your Claim Series, Cobalt, HC, N+, NX, KL, all those product lines are using the IEC cables. PowerCon True One are the power cables that are used for rental and staging products. All rental and staging products, and that has a 16 amp draw. Quick little note about, I know this question was asked earlier today, the cable length recommendations. So for category cable, Apson's recommendation is 100 meters or 328 feet. When you exceed 100 meters, 328 feet, we highly recommend to go into fiber options. Novastar has fiber converters that they provide. You have multi-fiber converters that are recommended from 100 meters to 300 meters, and then single fiber converters that go from 300 meters to 1500 kilometers. And these two boxes down here are what they look like. So the CVT 310 are these ones here. They're 1-to-1. They come as a pair, a transmitter receive pair. And then the CVT 320 is this box where you have up to 16 ports on the back of this box. So what you would do is wherever your processor is for input source, you would need 2 sets of fiber for 8. And so this will need 4 sets of fiber total for this box. 8 are on one output and 16 are on another output. And the fiber does need to transmit and receive. So two lines for each one. It is very important that if you need to use fiber converters during your entire sales, you specify what type of fiber. You cannot use, if we're speccing out multi-fiber and you tell us when you're going to install the wall that the client did all single fiber, these converters boxes don't work that way. You have to signify which fiber it is that you're going to be working with. So I say that because that ran into a problem this last year with integrator, and they didn't tell us about that until the week before they started installing, and it was a 3-month turnaround, 3 or 4 week turnaround in order to get the right fiber converters after they let us know that that's what they were what the end user ended up pulling was the opposite type. Yeah, that was a fun one. So yeah, cable limitations, 100 meters, 328 feet for Cat5. That is on the test. And you can argue with me all you want. I do understand that Cat5 can go farther than that. Apsen's recommendation is 100 meters just to protect data streams, data integrity. Calculation. Let's start off with the easy calculation first, and then we'll go to the fun power calculation second. First things first, calculating data capacity. There's three things that we need to think about when calculating port capacity for data usage on the processors. There's what is the total available pixel for the controller, and what is the total available pixels for one port. That's why I was pointing out those maximum resolutions during the controller section. Is you have your controller resolution, the maximum number of pixels that the controller can do, and then you have your Ethernet port capacity resolution. Then you want to know how many pixels one panel is consuming. We're going to go into how to figure that out here in the next slide. And then knowing those two numbers is how we determine how many panels can be maximum run off of one port of a processor. So I like the Acclaim 1.5 panel a lot because I do this way too much that I have these numbers memorized. We're gonna do a demonstration here of how to figure this out using the Acclaim 1.5 Plus. The pixel count for one Acclaim panel is 384 pixels wide by 216 pixels tall. And if you're ever like, how do I find out what one panel's pixel capacity is if to figure out what the right processor is? There's two locations to look. If you are connected to the processor and you're looking at everything on the processor, on the receive card tab, there's the red section there on the receive card tab shows you the size of one cabinet when you read it back from the wall of one cabinet for the pixel size, width, and height. If it's way early in the design application here, you don't have the panels in front of you or connected to it, you have no way of connecting to a panel electronically. You can either, almost all of our spec sheets are on our website, except for a few of the newer products. You can go onto our website, pull the spec sheet down for the model that you're working with. If the model that you're working with is not on the website, call us at tech support line. We will gladly get you the right model. If it's an end of life model that you need the spec sheet for, give us a call. We can give you end of life model spec sheets. Or if it's one of the new products that isn't on the website yet, we can give you that spec sheet also. But there's in the physical parameters section, the top section, there's a line that says pixels per panel, and that gives you the width and the height of pixels per panel on that spec sheet. So in order to calculate how many pixels one cabinet is utilizing, you multiply those two numbers together. So that's going to give you how many pixels total are on this entire cabinet right here. And that comes out to 82,944 pixels total. The next thing that you need to do to figure out how many panels max can be daisy chained together off of one output port from a processor, you need to divide out the port capacity. Apsen's recommendation is 575,000 pixels per port. And then you have your panel matrix for the 1.5 of 82,944. You divide those numbers and it comes out to 6.93, yada, 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 yada. You can't have less than one panel. So just not forget about the decimal point, and that gives you 6 panels max per port. I will get people that say, but Novastar says their ports can handle 650,000 pixels per port. And yes, that is what Novastar claims. But Apsen, we want to make sure that you do not exceed the processor capacity when trying to figure out your numbers. So remember what I said about the VX4S-N? It has a maximum pixel capacity of 2.3 million pixels, and it has 4 network ports. When you divide 2.3 million by 4, it doesn't come out to 650,000 pixels. Same thing with the MC-TRL 4K. You divide 8.8 million pixels by 16 output ports. That doesn't come out to 650,000 pixels. So you have your port capacity that it can go up to 650,000 pixels, but if you max out ports 1 through 3 at 650,000 pixels, you're going to be taking pixel capacity away from that 4th port. So that's why Epson's recommendation is 575 pixels. So you're not running into that port capacity limitation on the back end of the controller limitation on the back end of the processing. So we just figured out that one port can handle 6 panels max based on the 575,000 pixel Epson recommendation. Let's put this into an example here for you guys to play with in your minds. A full HD resolution wall, which is 1920 by 1080 resolution of the Acclaim 1.5 Plus, is a 5 by 5 panel matrix configuration. You multiply 5 panels wide by 5 panels tall, that's 25 panels total in this design. In order for us to make this, to wire this wall and not exceed capacity, you can only do each column of panels, because that's 5 panels that we're not exceeding the 5th. People will tell me, but you said you can do 6. Yeah, you can do up to 6. You don't have to max out the port. Another thing that comes into account here is Novastar has what they call the rectangle limitation in their processing. It wants to finish outlines. So if you go up 5 panels, then end it over here on the 6th panel, it wants to factor in all these pixels to make it a perfect rectangle. So when you're doing your wiring, you want to finish in perfect designs like rectangles, straight lines, squares. You want to finish in exact designs, not finish in the middle of a line, because in its processing, it's going to finish out this wall. It's going to finish out this row, and it's going to give you an error that says you're exceeding the port capacity, even though you're not really exceeding the port capacity. In its processing, it is. And actually, one of my demo walls in here that I will show you on the software tomorrow when I connect to it, I am actually doing that. And it's not recommended to do, but it's my showroom, and I had no other choice to do it. So do as I say, not as I do. I think that's the situation that's going on here. So we identified that with this wall, the full HD resolution wall of the 1.5, we need 5 ports total in order to run it. If we do 1 home run per port, per column. So that there takes out any processor that doesn't have 5 ports on it. So the VX4S-N and the MC-TRL 660 that only has 4 output ports cannot be used for this wall. Anything else can be used because we have the number of ports needed for it, but these 2 would not be able to be used. What is the max for the UHD Junior port? Oh, the UHD Junior is the only one that comes out to perfect math. So UHD Junior is 10.4 million pixels. You divide that by 16 output ports on the UHD Junior. It's the only one that comes out to 650,000 pixels. what is the math for this situation? 1920 by 1080, then using the Epson. I don't understand the question that you're asking. Can you clarify? Oh, you're asking about my situation that I have up here. In this situation here, no, the calculations are the same. You're finding the number of panels maximum per port that you can do, but you don't have to go all the way up. So the math is this to find out how many panels max per port. Now, when you have a design, you want to figure out how many ports you need in order to make that design work. So in this situation, this 1920 by 1080 situation that I have up here, we already figured out that I can do a maximum of 6 panels in one daisy chain loop. So I have my wall that's a 1920 by 1080 resolution. How many panels how many home runs do I need in order to make that work is what we're figuring out here by not exceeding that maximum panel configuration. So I'm only using 5 because I can't go to the 6th one. So that's what is happening in this one. Yeah, no calculation needed. This is just an example of how to use it in the real world application. Okay, you guys want to do some practice math here? I'll give you a few minutes. This is easy math. I have some models here, and I give you the cabinet sizes here. These are the pixels, width and height. For the N+ here, the stuff in parentheses is the 4x1 cabinet size, and outside the parentheses is the 3x1 cabinet size. Do the math here and see how many panels max you can use on one daisy chain loop. I'll give you a few minutes here. I'll give you like 5 minutes and I'll be right back. Okay. That was about 5 minutes. Let's go through this math here and make sure we got the answers right. So N plus. Your 3x1 cabinet goes to 43,200 pixels, or your 4x1 cabinet's 57,600 pixels. When you use your Epson recommendation for port capacity, comes out to 13 panels for the 3x1 max per port, or 9 panels max per port for the 4x1 cabinets. And then these next sections here on each one, I'm just giving you an example of the closest that you can get to a full 1920 by 1080 resolution wall, how many panels it would look like, and design wise to get to full HD, and the number of panels, so that you can see kind of how many ports it would take to build these walls. So 5 wide by 9 tall of the 3x1 cabinet size comes out to 1800 by 1080 resolution, and that's 45 panels max. Or a 4 wide, 9 high tall of the 4x4 design comes out to perfect 1920 by 1080 resolution, and that's 36 total panels max. In this situation, you would need 4 home runs, because you can 9 is your maximum, is your height of cabinets, and as you did the math here, 9 was the maximum number of panels per port that can be done. So each column would have its own port in this design. Next one, the A0421, 288 by 216 comes out to 62,208 pixels for one cabinet, which comes out to 9 panels max per port. And then 6 wide and 5 tall comes out to 1,728 by 1080 resolution, which is 30 total panels. And that's the closest you can get to 1920 by 1080 resolution with this model. Then you have your CL cabinet down here, the 0.9, that's 640 pixels wide by 360 pixels tall. That's 230,400 pixels in one cabinet, which equals 2 panels max per port. And then a 3x3 design is perfect 1920 by 1080 resolution. Give you an idea, that's about the equivalent of an 83-inch diagonal TV. And you need 5 data ports in order to run said 1920 by 1080 resolution wall. Any questions over data capacity calculations? Data is the easy one. Everyone gets hung up on the power. Which is next? How many data ports for the last one? 5. 5 ports. Okay, power. Calculating power. So the first thing you need to do, we need to do for I can't talk right now. First thing that we need to do for calculating power is we need to figure out the maximum, the power consumption in watts per meter squared of one cabinet. And then we factor in our operating voltage, and that will give us the number of panels based on the amp rating that is used. Here's a good little example of what not having the right power capacity will do for you. Just a quick note, this was not the integrator or Epson. This was the electrician not giving the right voltage. It was spec'd out at 208 voltage, and somehow we were recording only 187 volts on our multimeter for each line. So not sure how the electrician did that, but this is what happened. All of our panels have a failsafe in it, built into it, so they will automatically turn off in order to protect it from overheating or damaging the internal components in any way. Someone asked me to put the last slide back on. Okay, 1 second. Give you a couple more minutes to write anything down that you need for this. Oh, that was the one that people needed. While people are writing this down, it's quick to note that operating voltage, our cabinets are able to handle both 110 and 208 volts. It is the power supply is designed that way. The operating voltage will just change the number of panels that can be daisy chained together on one circuit rather than there's no different way that you have to do anything. There's no switch that you have to flip. They're able to take both voltages no matter what without any change. Great. Seems like everybody's done with that. Let's go to this page. So we're going back to that Acclaim 1.5 plus because I just like that model. I don't know why. I'm just stuck on it. First, we need to determine the consumption that one panel has in watts per meter squared. So this is how you can find it for us. On the spec sheet, under the panel dimensions, it gives you the size of one panel in millimeters. So for all of us that are American and we don't work with millimeters that often, we are trying to find watts per meter squared. So we have to multiply this section here by 0.001 to get it to meters squared. So your physical size of one cabinet is 0.610 meters width and 0.343 meters high. And you multiply those two sizes together to give you the area of one cabinet, which is 0.21 meters squared. If you do the actual math, it comes out to a much longer decimal place. I just always add it up to 2 or 3 decimal spots. Once you get the panel ratio size, so your area of one panel, the next thing you need to do is factor in the maximum number of watts per meter squared that that panel is consuming. And the number on this page is from our engineering team is based on 1 full meter. So that's why you need to factor in the area of one panel. And then down here in the electronic parameters of the panel, there's the power consumption line that gives you a max and an average watts per meter squared. So the first number is the maximum watts per meter squared, and the second number is the average watts per meter squared. We factor in our power consumption for daisy chain loops off of the max max is the panel running at 100% brightness or initial startup and power cycle of the panel. That way we are not exceeding the maximum power consumption, even though the panels are not taking that much watts per meter squared the entire time that it's running. We want to factor in those because nobody in their right mind runs a wall at 100% brightness on plain white all the time, unless they want people to feel like they're going down the tunnel to the end of the line. You will never see it on 100% brightness at white. Extremely long. But that's why we factor it in based on the maximum value to account for those situations, power surges, stuff like that, and protect the wall from shutting down on people. And so in this situation, 610 is the number that we use. So then what we have to do is multiply these two numbers together to give us the maximum watts per one panel of the Acclaim 1.5. So one panel is 128 maximum watts per meter squared for this model. Ouch. So the next thing we need to know is what is our operating voltage? What is the electrician providing with us for us? If this is a fixed install application and it's not a brand new build, 9.99999 to the infinity times out of 10, the electrician is going to always give you 110 or 120 volts. It's what they do. So you have your two operating voltage options, and then that you can use 110, 208. Is there a power safety reason or other reason that Absen gives power consumptions in watts per meter squared instead of watts per panel? It's something that engineering does. I don't know the right answer to why engineering gives you the full meter. I think if I remember right, I've asked this question before. The answer was that number is based on the parameters that are given in order to get it approved for use in America. So in order for us to get this stuff certified for use in America, we have to give them an entire document that shows all these parameters and electronic configuration stuff. And they ask for it in just watts for 1 meter. So that's why they just put that number down, and instead of putting that on the spec sheet, because they already have that number. Had the same question twice there. Yes, it would make more sense, but it's hard to change stuff in paperwork. Now, operating voltage. Anybody that has taken that's CTSI certified or CTSD certified, they'll recognize this next section as Watt's law. You have the watts for one panel, you have the voltage that you're using. Now we're finding how many amps one panel is consuming based on that. So when you have this here, you are dividing. So you take your 128 watts for one panel, you divide it by 110 volts, and it comes out to 1.17 amps per panel. Same thing with 208. Take 128 watts, divide it by your operating voltage of 208 volts, and it comes out to 0.62 amps per panel for one panel. And then this, I'll let people write this down, give them a little bit of breathing room. The next thing you have to do is you have to factor in the lowest circuit value. And more times out of not, it's the 10 amps on the cable that we rate our cable at, and not the 20 amp circuit that the electrician always, I'm not gonna say always, almost always provides. I don't think I've ever seen an electrician provide me with anything other than a 20 amp circuit, quite frankly. Do you offer a higher rate of cable for fixed install stuff? The IC cables are either, we say 10 amps because that's a safe thing. If you look online, most IC cables either come as a 10 amp rating or a 13 amp rating. We just say 10 to use the lower number to be safe. And then our PowerCon True ones are 16 amps. Okay, next one, like I said, factor in that lower ampage rating into how you figure this out. So did I fix this yet? No, I didn't. If you ever go onto our website and use the screen calculator, this number is going to be slightly different because Epson is now doing this recommendation off of 80% capacity, so that we don't, oh my gosh. So we're giving you that headroom for on it to protect it from power surges more. So we highly recommend doing 80%. I haven't updated this slide to correspond with that. So this here is factoring off of a full 100%. The test is also factoring off of 100%. So do it based on this number. So your minimum rating is that 10 amp cable, because the circuit's 20 amps, whatever the smaller number is what's being drawn. You have your 10 amp rating for 110. You divide it by the number of amps for one panel that you found, which that was 1.17. And let me actually bring my calculator over because I didn't do everything. So 10 divided by 1, not 0. Come on. 10 divided by 1.17 comes out to a massive decimal place. And since you can't have less than one panel, just forget everything after the decimal place, and that's your answer. 8 panels max in that situation. And then you have 10 divided by 0.62, and it comes out to 16 panels max per 100%. Now, if you, when I update this, it's actually going to be 8 here. So 80% of 10 is 8. So instead you would do 8 divided by 1.17, and that is 6 panels max. So if you ever go to our website, the actual value that it does its power math is 80% capacity. Hopefully I didn't confuse too many people there. But for the test, you can do the full 100% 10 amps. Just for people's understanding, so they're on the same page. A little note about power distribution, the number of circuits that can be pulled off of one 60 amp. This one here is a 60 amp circuit using 16 amp home run cables, PowerCon True ones. So you can do up to 3 daisy chain runs of cables off of that one 60 amp circuit. You can't exceed 3 because that's drawing 48 amps off. If you go to the fourth one, that's going to be 60, what was it, 64 amps, and that will cause the circuit to trip. Anybody want to practice? Practice makes perfect. Let's practice on the N4. I give you basically all the information that you need here, assuming this is the 10 amp rated cables. I already gave you the meters. I already did the math for you to give you the meters. It's 1,152 millimeters wide, 288 millimeters tall, 10 amp rating, and we're using an operating voltage of 110 volts in this situation. Question here, it said, missed why you divide by 10 instead of 20. You want to use the lower number and when you're factoring it, because that's the maximum it's going to draw off of. So you can plug two 10 amp cables into 120 amp circuit because the cable is only going to do that maximum 10. You're always limited by the smallest number in ampage of anything in the chain, whether it be the cable or the power supply or the circuit at the in the circuit breaker. You're limited by whatever the smallest number is because that's all that's going to be drawn off of it. Continue the question, wouldn't you have to double the number at the end of the calculation then because both cables are plugged into the 20 amp circuit? We're only finding the power chain for one cable, one home run from the wall. Yes, that 20 amp circuit's going to, if you use two cables on that 20 amp circuit, it's going to be doubling it, but we're only wanting to find how many cabinets can be daisy chained off of one circuit, off of one cable. No problem. Give you one more minute to look at this, and then we'll walk through it together, hand in hand. Okay, let's walk through this hand in hand. So first we want to find that area of the one cabinet, which comes out to, when you multiply 1.152 meters by 0.288 meters, comes out to 0.34 meters squared. And then you got your maximum watts per meter squared from the spec sheet, which is 434 watts. When you do that multiplication, comes out to 148 watts per meter squared for one cabinet. And like we said, we're using an operating voltage of 110 volts, which comes out to 1.4 amps per panel. And then we're using that 10 amp rated cable. So we divide 10 by 1.4, and that gives us 7 panels max daisy chained together. Now remember what I said about the N Plus series. There is multiple sizes that can be done for this. So the 1152 millimeters is the 4x1 module cabinet design. So you can have different number of panels that can be daisy chained together based on the cabinet design that is being used with this model. So make sure when if you're using the N Plus series and you're trying to figure out the math for the N Plus, you're using the right cabinet size, because that will change the number of panels that can be daisy chained together off of that one cable. Let's do one more here using the XD6 Plus. So we have your physical size there, 640 millimeters wide by 960 millimeters tall. This one uses the 16 amp PowerCon True Ones, and they're using an operating voltage of 110 volts. It would help if I unmuted, huh? So you guys can hear me. Okay, let's walk through this one. We got our physical size of 640 millimeters by 960 millimeters. So you get that into meters, it's 0.64 meters wide by 0.96 meters tall, which comes out to 0.62 meters squared. And your maximum watts per meter squared from the XD Plus's spec sheet is 800 watts. When we do that math, multiply it by 0.62, comes out to 496 watts per panel. Then you're using the operating voltage of 110 volts. So 496 watts divided by 110 volts comes out to 4.6 amps per panel. And then it's using that 16 amp draw. So you divide 16 divided by 4.6 amps comes out to 3 panels max. 9 times out of 10, most places use 208 volts for outdoor panels because of this reason. You can daisy chain more panels on 208 volts rather than 110. Any questions over power? What are the watts, max watts for the X5 and Polaris? If you email us, we can get you that information. I don't have those documents up on my computer right now. But we do have that stuff. Just email either me or if you have any issues, if you have questions like this, you can also email tech.support@usapson.com. And that will get to anyone in my team, and someone can always get you information like spec sheets and CAD drawings or anything like that you need for our cabinets. If you reach out to the tech support, it will get you that information. When using the calculation, it is taking it off of 80% capacity on the website. I will show you guys that in a second. Finish this here. So daisy chain, you go your source into the processor and then Cat5 through the panels in the maximum number of panels associated with it. So if you just follow whatever order you want, I will tell you there's no wrong way to daisy chain a wall. Just make sure it works for whatever you're doing. I know real staging companies, they prefer to go horizontal along the wall because as you're rigging stuff and lifting it up, it's easier just to plug in all the cabinets and then lift it up to the next one, put all the cabinets on, and then wire it along the entire row. So going left to right, top to bottom, there's no wrong way to do it. Whatever makes sense for your situation is perfectly fine. As long as you are not doing anything like, as long as you're following the rectangle rule that Novastar has, there's no wrong way. So let me clarify it. There's no wrong way as long as it's following the rule, which is straight lines, perfect rectangles, squares. In situations like this red down here where you don't plug in these two, it wants to finish out that row. It wants to finish out these columns. It wants to finish out any of these panels that you don't have in the chain and make it a perfect square. Story time about a nightmare. Got a nightmare call. Client says our wall lost its configuration. We need help. The integrator, this is all they sent me for drawings here. If you look at it, it looks like, I don't know, it looks like three rows, 12 columns, because you're following this lightly colored line here, thinking, oh, that's the data line doing all this stuff. Come yada yada yada. This looks like it's going to be easy. Map it out on remotely. It fails, and I go, and nothing is fixing it. So I'm confused. Finally, we start taking modules off. Come to find out, this is how they wired it. it was actually each one of these squares is actually the modules. So this is one panel, this is a second panel. It was our in series in landscape mode. It was actually 2 rows of panels and 18 columns wide. And then the actual wiring diagram, because of how the ribbon cables were in the wall, it actually went the first receive card here went this way, this way, this way, and then it jumped to column 3, came back to column 2, and went down to column 6. I mean, went down to the bottom of column 3. And it repeated this 6 times across the entire wall. So if you do something like this, document it, please, for whoever has to service it in the future, because this was this took me about 3 hours of investigating on site to figure out what the heck they did, because nobody documented this is how they actually wired it. Document, please document. I'm not even going to repeat this page. You just need a cable, you need a daisy chain, cables that are important, control PC, USB connection. It's a USB A to USB B connector. Where's my USB B? Someone stole my cable. Dang nabbit. Can't leave anything in this room. USB A to B connectors for control to connect from your computer to the processors. Your connection source can be HDMI, DisplayPort, DVI, any of those things. And then you have your main your home run data line from the processor to the first panel in the daisy chain loop. That is the end of day numero uno. I know I talked fast. I'm sorry. Home run data line is the main data cable from processor to the first panel in the daisy chain loop. Rory, you raise your hand.
Sorry, I misclicked.
I'm sorry, I missed that, Rory. You're good? Right, yeah. Any other questions before we end for the day? There's a question here, 1 second. Question about today, will there be a way we can rewatch this? I came in halfway. Reach out to the Absen ACE email address, and Jason can, after today, Jason can work with you on getting the video for you to use. Any other questions for today before we call it a day? Will we get a copy of the presentation slides? I can. Email me directly. My email is on my business card up there. I can give you what I have that is I can share. tomorrow, 1 p.m. Eastern Standard Time. What is that? 11 a.m., 10 a.m., 10 a.m. Pacific. No problem, guys.